This is a test in the... I was testing my audio. Okay, we gotta put this on shuffle. We can't be doing this today. I immediately realized it was not on shuffle. Because yeah, we can't be doing that. We can't be doing that. Gotta be on shuffle. Hello, bud. Hello as well. So you gotta put it in the Discord. Yes, there we go. Okay, nice. Alright, some more sim today. That's the goal. Gonna need to get another coffee soon though. But thought why put a damper on the whole thing and wait? You know, might as well just you know, just take a break. But yeah, I do have more coffee in the what do you call it? The fucking... the coffee holder? The thing. The jar. the thing that... I don't know what it's called. I forgot what it's called. A carafe. It's called a carafe. The more you know, right? It is called a carafe. Okay, so let's get rid of this. This is old. I don't know exactly what this was for. This was doing the yeah, this was doing the blur, but we do it in here anyway. So a couple of things that I noticed. This blur is actually more expensive than I thought, and so it's of my opinion that we should SIMD it. Like we SIMD, it is a carafe. It is a carafe. I did probably, you know, it took me longer than it took you to figure it out though. It did take me a long time. So we SIMD all of this shit yesterday. The Sobel stuff. And so we can probably do a similar sort of thing with this. It should be a lot even easier. But yeah, we should do exactly this. To save some operations, we can actually maybe go 0 to 2. And so we don't have to do this. Preload the kernel into registers, like we did here. Also, I'm wondering, is this good practice to like have these registers here? I don't really know. How long to keep registers in scope SIMD? The compiler can run out of registers and forces a spill to stack memory. How many? How many? I think it depends on our L1 cache, but like I think we have an AMD FX 4300 L1 cache, and we have 256 kilobytes. So okay, so I guess we can do the math here on 128 bits, right? So this is 9, 9, 9, 1, and then we have a lot more as well. I wonder if we are spilling over. Should they be static? Probably. They probably should. You're so correct. I mean, it's not like they're gonna change though, or like, you know. But yeah, they can be static. Nice catch. You're a nice catch. But yeah, they can be static. Because I have this pre-compute here in this file, so it's fair. But I guess we can count them up, because I also have these that I preload. But I suppose we could also not preload things, but I did it because it's in my head faster, of course, to just preload them once, because they're being used every single iteration like a billion times. But we do preload a lot, like all of this. Like this is a lot, right? This is insane. So, or this isn't actually preloaded. This isn't preloaded. No, those are just floats. This is what's preloaded, all of these. I feel like this should be enough though. So 128, 128, 128. So this is 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20, 23. Let's do the math. So that's 2944 bits. Plus 9, 9, 9. So 27, 28. So we're looking at about 41. No, 51. So that's 6528. So that's only that's less than a kilobyte. That can't be correct, right? Or is this? I guess it is. Like, really? Is it really? It's that little? Like, that's crazy, actually. Memory is that much? Really? It has that many floats in it? You do that many floats? Because each of this is 4 floats. That's a lot of floats that you can keep in L1 cache, I guess. I guess I never did the math on it, but that makes sense. And if we want to be correct, we can make all of these static as well. I don't really know if it's really necessary, but sure. I wonder if you can do a thing in Rust. I wonder if there's a thing you can do in Rust where you can do the static const thing, where do the static const thing where you fill this in at compile time, right? They have that thing, right? You can't do this in C though. Not necessary. Yeah, I mean, the thing is, when I make globals, I mean, to be honest, like, I don't think anybody else is gonna be using the code other than me, because it is, you know, Windows XP, but, you know, yeah, maybe somebody reads it and finds it interesting or whatever, But sure, we can make it static. But I kind of wish that we had that thing that they have in I think that they have it in here you globals with that static look off, I guess. I mean, like, I have a lot of globals in this project. Like in here, like these are all globals because there's no need for them to be in a struct. If they're in a struct, then it would just literally like be the exact same thing as them being here. You know, there's no need for them to be atomic or volatile since they're only, these are all like config params that are changed from the main. All uppercase? No. No. I only make enums uppercase, things that are enums uppercase. And I guess these globals, I make them uppercase, yeah. I like globals to be uppercase. This one is an old one that wasn't supposed to be a global, so these are lowercase, but I typically like them to be uppercase. Yeah. It's just the way I like it, I guess. Everybody has their own thing, but yeah. Yeah. Maybe globals are generally uppercase to not confuse the program. I'm a confused program all the fucking time. Okay, so what I was going to do is I was going to go 0 to 2 so that we don't have to do this. And also we can preload this into things. I mean, enums are always uppercase, but I've changed to doing my globals uppercase because I don't know. Generally don't exist to not confuse the program. See, that's where we disagree. I don't like see the point in not having globals. I think the whole like clean code, let's pass around a pointer to a fucking struct that has our config, like it just makes the code needlessly verbose, and then you end up having a bunch of pointers and pointer dereferences that are not necessary, and things get slower. I think globals make a lot of sense actually. Especially in like a project where you need absolute speed above everything else. But yeah. So yeah, I was gonna preload these, but not ones that are shared between files. I disagree. I just do not think that writing into everywhere where we take in a you know, a global like config params, if I had to do, you know, config params pointer, you know, CP or whatever, like that's slower than just having an externed variable that tells us if we're asymptotic or what our growth type is. It's literally just faster to have the global that's externed, you know. But I guess I get people's problem with it, but I also think it's completely unnecessary. So this is going to be the Gaussian kernel. This is also 3x3, but most people aren't writing 3D renderers. I guess so, but like then again, like, you know, it kind of lends itself to the style. Yeah, I mean it definitely does, but like, yeah, I mean I agree with you on that one, but yeah. I mean, that goes for everything, though. Yeah. It does go for everything. So we can do the same thing, I think. Actually, I don't know why I'm doing this in a separate thing. I should just do this like literally here. I don't know why I'm also like the X and Y are obviously going to be the same thing in our kernel as the Z, so we can just literally do this here. This is also a global. So funny enough though, what we do have to actually pay attention to is if this is initialized before we actually initialize the kernel, compute it, you know. So yeah, it is. That's what I was kind of worried about. So I got to do that first. But yeah, I will have to clean this up at some point, all this shit for our setup, but like for now I don't. I'm still like adding on to it, so there's no real point. Okay, so we load all of that shit in. Now we have to do the same thing that we did here. So it's gonna go 0 to 2 so that we don't have to do the extra operations to add 1 every time. And okay, so how do we do this? So we want to load in 3, load in 4, yeah. Okay, so this C IDX, okay, so we're also going to load in H, right? Oh, that's where this is going to be different. Okay, so we need to load in H as well to multiply it times this. So it's really loading in H for 3 of these. Okay, so let's do that. And then having the sums so that we add once, I guess. Okay, so yeah. Then I'll load in this going across, I guess. Yeah, and then just multiply times the kernel and then add the sum. So it's really, okay, so it's just going to be yeah, so we just load in here this, and then this is just going to be x minus 1 actually. Yeah. Right, I have to do the mole mask, which is, it should be the same exact thing. The mole mask is what makes it so that because we only need 3 lanes. So there's that too. And then we just add it to the sum, and then we just add it at the end to US. That's what I'm gonna do, I think. Yeah, is that... No, because then you have to horizontally sum. And we don't want to be doing that. I guess we're gonna have to horizontally sum anyway, actually. So that's kind of a pain in the ass. So Yeah, that's just actually necessary for it to happen. So that does suck. It is necessary. Yeah. And then here we have to horizontally sum. It's the only thing. And I do have a thing for this. We just actually set it to S. I think so. What is US again? That's what everybody's actually asking right now, but usum is, we set it to 0, right? Before this anyway. It's not a moving average, right? Yeah, we set it to 0. So you can just set it to S, yeah. Okay. So that's how that works, I think. And we can do this inline, of course. And that's that. Yeah, just do it all inline. I think that's correct. Oh, wait a second. Yeah, we do need to do the mole mask, right? So sum equals mm mole ps with sum and the mole mask, right? I almost forgot about that. Okay. Cool. I've been working through CSAPP now because I just got the book. It was a birthday gift from my dad, and it's been really interesting. It's cool that they put in here like all of these like historical kind of facts about different operating systems and like kernels. It's really fun to read. It's a really good book. But yeah, highly recommend it. I do. All right, sounds good. I still do leave some questions wondering here, like, is this faster than if we just declare variables inside of here? Or does it, I mean, I think it compiles all down to the same thing, but I do wonder about that sometimes, like how it naturally caches this sort of nested loop, if it's just faster to actually like keep this in here because it's guaranteed to be in cache or something. You get what I'm saying? But I have no clue about that. I have no clue. But this is like typically how I've been doing things now, is just keeping it all inside of here because of cache. But maybe I'm stupid. Have a good night. How are you? What are you doing? Do I create the GUI library? No, I'm sorry. I don't. It's actually just Win32. I wanted to show off what I'm doing, but I'm going to illegal indirection. Wait, what? Illegal indirection. Sorry, let me just get rid of this bug and then I'll Maybe I need to cast this to an int specifically. Illegal indirection. Well, I wanted to show this off for you, and now it's mad at me. Is H used somewhere else? It is not. Okay. Let's just straight up use CIDX and then see if it... H is the thing. Yeah, it is. Okay. That's weird. That's weird that the macro got that mad at me. Anyway, oh yeah, it looks kind of weird right now because we were playing around with the graphics, but it's just basically like a 3D rendering of a 2D cellular simulation. And for a challenge, I wanted to do it on Windows XP. So it does look kind of weird because we were playing with the graphics. But we can change the colors of everything, which is neat. It is kind of hard to see because we did change the color to anyway. Anyway, so I didn't create the UI. No, it's all sort of Win32. All of this is Win32. How they used to create graphical applications back in the day. Anyway, I think it's pretty sick. But I'm trying to make it as fast as possible, so I'm like manually vectorizing things and rewriting the code over and over again to the point where I can get it. I want it 60 FPS, and my goal is to make the field bigger. I really want to make it like 42 by 42 by 42. I think it's slim pickings for a Windows XP GUI library. Yeah. It isn't fast. Like, the thing that you may notice is, like, when I press R, you may notice that it takes a while to reload. It is not perfect, but I think it actually looks pretty. I think, like, this stuff is actually, I really like the Win32 actual graphics library. Like, even though it is slow by today's standards, I actually prefer the way it works to, like, something like GUI or Nuclear even. Like, I really have come around to it. All of these buttons, you basically just like put text boxes over buttons, and I don't know, it's very, very customizable. It's very customizable, and also pretty simple to hook up to. Like, I have function pointers basically that when we click a button do things. The only thing annoying about Win32 is scroll bars. Doing this was so incredibly fucking complicated, actually. Like, this was like, I actually just straight up, this is the one thing in this engine that I've taken from Stack Overflow, was the goddamn scroll bar. Like, you can see when we did it on stream, we literally, like, we could not figure it out. The code for it is so complicated. I can actually show it. It's like, the scroll bar shit is actually ridiculous. Where is it? I want to show it off because of how, this is the code. This is the code. Like, I have no clue what this even does. To be honest, I have no clue what any of this is doing. I mean, we had to modify it, actually. We didn't just take it straight from Stack Overflow, but yeah, this is not very clear in the documentation at all to figure it out yourself. Like, you have to get like this enum for the specific type of action because it's based on where it is or something, and then you have to have, I have a global here that tells us how where we are currently, which makes sense for a scroll bar, but how you interact with it is not very simple. Like, to be fair though, my GUI library that I did for my game engine is also fucking complicated, but it abstracts it away more. Put a question there that will explain the code. You want me to put a question mark here? When we put it on GitHub, they're gonna see it, and then they'll explain it to me. So there you go. You got a shout out in the code base. Okay, back to what we were doing. Anyway, nice to see you, Unbreakable. I hope you're doing well. Okay, so we just need to replicate this for all of the blurs. The blurs, by the way, are for central difference, because basically Sobel is doing a convolution in a cube around the center, right, of each cell. And our central differences do up and down, so it's axis aligned basically. And so to make up for that, what we have to do is do a Gaussian blur beforehand, so that the corners basically get filled in, if that makes any sense. The corners end up seeping into the axis aligned places. So that's why we have a Gaussian blur before we do the central difference stuff. The reason why we do the central difference stuff is because during reintegration in 3D, Sobel actually is extremely biased towards positive, 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 and so all of the mass ends up flowing that way. And that's actually something I discovered later with this math, that in 3D Sobel convolution doesn't really work, which makes sense because it's mainly used in images, which are 2D. So I was wondering why it was so biased, the entire simulation, for so long, and it turns out that I wasn't crazy. It was just oh, I see what I did. I see what I did now. I didn't put the channel at the end, so I was using the macro wrong. There we go. But yeah, that's the story behind how we ended up doing this with the blurs. And why do we have a different function for each one? Well, for speed. That's literally the only reason, because we don't want to have a switch case in here, because it stops vectorization. So that is the reason why. Or not even a switch case, but an if statement in here just stops vectorization. So we don't want to do that. This one, is sum actually packed? It's a good question. I don't really remember. It is padded. Okay, so it doesn't have a channel though, so it's just the padded index. That wouldn't be a compiler optimized? No, unfortunately. When it's called thousands of times, no. Especially in a multi-threaded program, if I just simply had an if statement here that said if border torus do this interrelation, and then else if, or if I had a switch case, there's no guarantee that this doesn't change during runtime. This isn't a constant. This is something that you can change via the UI that I just showed off. So there's no guarantee that that won't change during the iteration of this, right? Because we have, 4 threads, and one of them is, the main one that's taking in our input. So if that can change during your frame, then they can't vectorize that because there's no guarantee. Now, if it was a compile time define or a constant, then yeah, but yeah, it doesn't actually. Especially on an old compiler like this, it doesn't actually automatically vectorize. And the proof is in the pudding because we've seen a 6 times performance increase from vectorizing it manually. Like literally. I can't, you know, compile it right now, but yeah. Can't I just like oh yeah, it's gonna compile again. To be honest, it's so frustrating. I wish that you could just like do it without, but yeah. If having conditional flow will noticeably affect, shouldn't function calls also be eliminated? Having one function call is really not a lot. Like this happens once a simulation step. So yeah. You run the previous exe? Yeah, I can. If you want me to go there. I just wanted to show off like the amount of time. Bro, what about the ones in the loop? These? What functions in the loop? There are no functions. This hsum is a static inline. This is a static inline. But yeah, I mean that is literally just inlined. Like this just literally gets inlined completely. There's no overhead. Are these macros? Oh yeah, those are macros, yeah. These are macros. These are just literally the indices, how I compute the indices. So yeah. Yeah. Yeah, I have to hsum this too. Yeah, we also have to do the mole mask. Okay. That should be literally it. Yeah. Just gotta make sure that you don't fuck up anything here, because if you do, then it's like impossible to figure it out later. So. The funny thing is, actually, we don't even need these to be different now. I think. For the blurs. They're all the same, actually. So the reason why they're all the same now is because we basically, so borders, the border is basically how on the edge, right? We wrap around or we create a wall or whatever. What we're doing now with these arrays is I actually pad them manually and fill them in with data that mimics the border. Or, I mean, it just does the border itself. So instead of having, you know, different functions that do it, I already actually, basically, there's a little gutter right next to every, you know, edge of the giant cube, right? Where we put in, you know, either zeros, or we fill it with the other side, or we repeat the neighboring cell. So actually we don't even need these extra functions, so we can literally just like not do these. So that's nice. So yeah. that's nice to know. But I didn't even realize that. Yo, what's up, Yash? I totally forgot that I did that. So right now we can just do this call some blur and then call it a day. The switch case for what we do actually happens when we pad the border manually, and that takes a lot less time than if we have an if statement in here. I can tell you that. I have to go to that header, which I have here conveniently. Yo, what's up, Watt? What's up, Watt? I'm a master? Master of all trades, jack of all trades, master of none. Yeah, where do I actually implement this? So it's here. So I can just literally call this and get rid of this. Yeah, some blur, h blur, and that's it. Sometimes better than a master of one. I'm a master of none. I'm definitely a master of none. Okay, we can... Oh my gosh. I hate it when it does this. Go away, please. Yeah, that's what I... Oh, fuck. That doesn't seem right. Maybe it's fine. Oh, maybe it's fine. No, it's not. No, it's not fine. Yeah, what is that? What the fuck is that? What? That's what I was called in school. A professor said that I was a jack of all trades, master of none. So fuck that guy, I guess. Okay, so we fucked this up for sure then. Oh, yeah. So that would be where I fucked that up. I just had to look at it for a second and then I figured it out. Alright, seems about what it was before. I feel like we gotta change the color, bro. Kind of hard to see. It's also interesting that like stuff gets stuck on the walls. I actually think that's no, yeah, it does get stuck on the walls. So that's a newer thing that's been happening. So we do have to investigate that. That's not supposed to happen. Okay, so how are we feeling? 124, 156, 126, 239. That's not good. What should be dark gray? Yeah, I tried to make it dark, but then it looks bad. I could show what it looks like if we make it dark. It does not look good. It looks awful. I don't know why. I think it's just weird because our lighting is bright, and so if it's in like the blackness of space, it just naturally ends up looking weird. But I can show off what this looks like if we just put a 0 here. Oh. Yeah, it just looks very strange. Like, it just looks weird. I guess we can make the lighting darker so that it fits better, but it does just look very, very odd. It just looks weird. Even if we use darker colors for the thing, it just kind of Just kind of seems weird. Yeah, so I expected that to speed us up a lot more, actually. So that's kind of a bummer. The camera's a bit too close, I guess. I mean, it's kind of hard to see what's going on if you aren't near it, because it's a cube, so you kind of have to stand in it. All of the other squares that are next to it or whatever are just different views. The main simulation is the one in the middle. I think I can parallelize this more. Oh my god, my eye. So what are we solving right now? Basically this blur takes a long time, and so I'm trying to make it not take a long time and vectorize it. So I'm trying to see if I can basically get away with doing something like this, if I can manage it, but I don't know if I can. No, I don't think I can. Because this has to be horizontally summed, so you can't... Yeah. Yeah, you can't. Yeah, it's not possible. There's no way, because this can't be... You can only do the innermost. Doing this does nothing, because this is nothing, right? It'd be possible to do maybe... Yeah. Yeah, never mind. No, it's not possible. It does suck though. I think so. Just to prove my point, I wanna just test the time that this takes, and then see if we. I don't think anything is going to. Oh yeah, nothing is going to really happen. But I want to see. So yeah, that is a lot. That is a lot. It's crazy because we got the Sobel down to so low. I assumed that we could get this down to really low as well, but I suppose not. Like, our Sobel is so cheap now that I assumed that this would be... I mean, maybe it's not that cheap, but yeah. Yeah. Does kind of suck. We could make it a toggle to toggle off the Gaussian blur. It's not like the end of the world, but yeah, I don't think that we're gonna get any faster than that. Yeah. That's a bummer. I really thought that we could just like vectorize it and it would be a lot faster, but yeah, I don't think that we can make it any faster than this. Branchless fuckery with a toggleable variable. Yeah, I could just make it a toggleable thing, but yeah, it does suck that it's just so expensive. Like 100 in that is a lot. Like 100 is a lot. So yeah, and the problem is that it's specifically like it's not necessarily the biggest problem, but it's going to be a problem because it doesn't scale well. Like if I change this to 36, you're going to see how expensive it is. As soon as we increase the grid size, it's just exponentially fucked. Like, look, it doubles. So, you know, it just scales so poorly. So, yeah. It's 3D though. It's literally the 3D problem. Yeah, not much I can do about it though. I did do this the same way, right? Like we load, yeah, we load fine. We do it the same exact way. Yeah, okay, well we gotta move on. That is what it is. What I was gonna do is actually, I can vectorize this as well. This is like really easy to vectorize. So that's like this might actually be auto vectorized, but we can do this as well, it's no problem. We do have to split it up once again. Is there space for some kind of culling? Yeah, I mean, so, no, not really. Not really, no. Am I blurring every single section? Yeah. Yeah. But it's multi-threaded, but, I mean, I already tried, by the way. I already tried just, like, not touching things where there isn't mass, but it makes it look really bad. So, because judging where there isn't mass is kind of not, you know, not possible. Just because of how the simulation works. So, yeah. Anything like that doesn't really work. We're gonna need two functions, one for soft clip and one for regular, once again, but that's no big deal for something this small. It's fine to go into reintegration for this, I guess. It's like, this is all in order, so we can just put it at the top. What did Windows XP errors do with blur? With blur do? I mean, so they did screen space blur. Like we're doing a 3D convolution blur. It's like cubed rather than it's cubed rather than, you know, squared complexity, you know. So it's like everything we do is like way more expensive. Which is why this project is kind of hard, is because this was math that's only meant for 2D, basically. We're already cheating a lot, so, with it, but. Okay, so this is no big deal. We just do plus equals 4, and then we just load in grid, CPU IDX, and then do the thing. So, you remember one episode in Black Mirror series where one person fell in love? Where, was that like the Bandersnatch one or whatever? I don't really remember. I remember there was one where they were inside of a video game or something. I don't really remember the specifics of the thing. But yeah. But yeah. Yeah, doing a horizontal sum is also really inefficient. I wish there was horizontal sums in SSE2. It would make us a lot faster, but we don't have it. So that's also a sore spot. So H needs to get multiplied times the time step, which is easy enough. What we could do here is just preload and there's a min. There is a min. I think I do it somewhere else. I don't really remember. Min PS and max PS, yeah. We can just load this in here. Could also just keep that around as well, but for now it's fine. So okay. Oh wait, no, we need to add it as well. There. And now you just store it into back. Yeah, that's a long line of code. I'm not gonna lie, that is a long line of code. Listen. I'm not gonna pretend here and say that that isn't a long line of code. It absolutely is. But that's fine. And I don't know what the soft clip is. I don't know. We can vectorize it. It's gonna be painful though. It's not gonna be simple. Like, because it's not just min and And max, it's different. So we have to do another step here. It's a sigmoid function. We can look at what it looks like. It's this. Can we do EXPF in SSE2? Exponent approximation. Oh, this is complicated. Okay, let's attempt it. It is not going to be easy. There's apparently this thing called the Taylor series expansion, which I'm looking at, which is in a way of approximating it. However, I'm going to have to copy a bunch of const boilerplates. That is kind of painful. So sorry, I can't read the chat right now. But yeah, there is no exp on SSE2. So we're not actually going to get a 100% accurate result. But then again, our that mode, which is soft clip mode, is technically just an additional mode that isn't like a main mode at all. So it's just literally this all the way down, I think. Yeah. Hold on, I'm off. Yeah, I'm off. The episode is called Plaything. I don't think I did. I stopped kind of watching it, Black Mirror, maybe like season 3 or 4. I wonder what they would have to say about all the AI stuff that's going on. I've never heard of this function, FM add. I have no clue what that is. What is FM add? Not found. FM add. Okay, so fmadd does not exist in this thing, but all it is it's a mul and an add. So that's all it is. It's, yeah, so it's literally just that, and that. So it's that, yeah. So you just have to do a series of these calculations going downwards until you hit 0. I'm going in the wrong direction. And that is that. It is very, this is very expensive. But we can give it a shot. There's also a different one. But I have no clue. I see I use IEMs. I do. They are truthier. Are the values the factorials you divide by? I'm not really sure. I have no clue. No clue. But we also have to return it. But you know what? If there's one way to go about it, then that is that. So we have okay. I don't know why I didn't do this, by the way. Whatever. Let's just pretend like that didn't happen. So, let us do let's just do this way because I want to step through it later. Okay, you can apparently do division. You can it's apparently possible. Okay, that should theoretically be it. Theoretically. This min and max don't even get used. Alright, let's try it. Where am I from? I'm from the United States, but I used to live in New York, but now I live in the southern East Coast. Oh, fuck. I just realized something. Alright. It's per channel. I forgot about that. So we have to iterate it outside and then do it like that. So not as simple as I thought, but whatever. To do this, we actually can just pre-compute this. I think that both of them are padded now, so you don't even need this. Therefore, you can just like calculate it later by just adding the index. But yeah, you don't iterate this. You just iterate inside now and just calculate it based on. Like that. Alrighty. Alrighty. No problem. It's just going to be slightly less efficient because we do have to iterate the channels on the outside. But that's okay. That's alright. Yeah, you still have to do this, right? For this type of blur, you recalculate the exponentials every frame. I'm recalculating it per cell. Soft clipping it has nothing to do with blur. We're not doing blur anymore. What I'm doing is I'm computing the growth for the simulation step. So that's what this that's what this formula is. It's basically like a sigmoid when we're reaching the maximum. Yeah. Should theoretically be everything. No errors. Okay. Okay. So we do have to be on RT mode for this. For this to work. I think it seems about right. So soft clipping. I don't really know how to prove if it's true, if it works. Really, it'd be like impossible to test. Because usually the effect is quite innocuous already. It disappearing doesn't really inspire a lot of confidence. I feel like, I mean, the growth step seems alright. We should also be testing though with its Sobel, because that's what it's supposed to be. I need to make a button for that, I know. Okay, that does seem correct actually. Now that we have the correct growth. Yeah, that does seem correct. It should be a very small change. It should get more volatile and more expansive, so that's pretty much what we see. It would be a pain in the ass to actually debug it, so I feel like we just kind of let it rock. It would be a real pain in the ass to debug it, because we would have to basically do a side-by-side with the values, and that would be really painful. So, oh, we didn't actually even like check the performance of this. I doubt it's gonna have any impact, to be honest. Holy shit, what the fuck? That can't be right. Sometimes it jumps up to 100. Wait, what? Oh, wait, that's because it's Sobel. That's because it's Sobel. Yeah, never mind. I had a heart attack there. Central diff will still be 100. Yeah. It's really interesting that central difference ended up being more expensive than that, but is what it is. Yeah, growth was already not a very expensive thing to calculate anyway, so doing that really doesn't actually change much, to be honest. Really, we should be focusing on changing F and V. Now, there's crazy latency on the chat. I'm not sure if that's due to me enabling ads or what. I don't know. Blame YouTube, not me. Or don't blame YouTube, because I'm I'm friends. Alright. I feel like I don't even need a switch case here. Like, they're all the same, right? Maybe not. Yeah, this one's interesting. Confess, the EXP be used in other places? No, that's my only EXPF in the whole thing. What I can do, though, is I can implement the same kind of vectorization when I do this. Which, I wonder if I'm trying to figure out in my head if I need this to be thread dependent anymore. So let's actually read the code and try to figure that out. This is basically the code. So the TTIDX depends on DPIDX, which is decided here. So we should always be accumulating into a thread dependent area anyway, at least there. Here this is PIDX. I don't know where this goes to, but I think, yeah, we're gonna have to actually read the SIMD code, even though it's like, oh, this isn't actually even SIMD. So this is PIDX, which is here. So this TT array does not need to be thread dependent anymore. Oh wait, it isn't even thread dependent. Wait, what? Wait, what? Wait, am I adding twice? That would be crazy. Am I really adding twice? I am adding twice. Or I'm not adding twice because of this. They have their own areas in the array, but that's not necessary because they're always going to be, they're never going to overwrite each other. So I can just turn this back into this. I had it so that there's no race conditions because they used to write over each other, but they don't actually do that anymore. They operate on completely separate parts. So that's something that we can do. So we can just index it just like a padded array instead of this, like this extra operation. So this TTIDX should just be a CPIDX, or rather this PCIDX that we already have. What I was going to do is I was going to do the same thing here because it's just the deferred growth step, but let's not even mind that for now, and let's just focus on, that's not even that big of, like, that's not expensive at all. That let me go to reintegration and then see, we are going to have to change a bunch of stuff in here. Like this has to be, the channel is here, right? Where's the C? Oh, right. C is that. Yeah. Right, because I manually unrolled it, yeah. So it's actually DCIDX is what we need to index it with. That is padded, right? Yeah, it is. It's faster to just do this because now we can vectorize it and not worry about that inner loop. I'm sure I'm fucking up somewhere here. That's gonna be a bummer when I figure out where I fucked up somewhere here, but what is this current? Oh yeah, current, right, because we're... Wait, but then... Oh right, I horizontally sum, yeah. That is true, okay. fine. Okay, that should be technically it. So let's see if I did it right. Redefinition, different structures. Very true. Very true. Okay. Is it because we're Sobel, or we appear to be Sobel, and maybe that's what's throwing me off mentally here? Yeah. Yeah, I think we're fine. Okay, it's hard to tell where the bottleneck is because we don't actually have good profiling, which is shitty on my part. I'm not really sure if we are, we are. We do count transposition in it. We do. We don't count this, but yeah. I almost wonder if we do a blur, if we could FFT. If that would be faster. If I just FFT instead of doing a manual convolution, if that would be faster. For such a small radius, it maybe wouldn't be worth it. But I'm just thinking about how many convolutions we do each frame and how cheap they are because of FFT. That might be what we'd have to do. Huh. We would need to pre-compute a kernel forward FFT it. The problem is that you're paying the cost of peak stream, yeah? Thanks, I really appreciate that. It's not easy, it's not easy. It's not easy to calculate if it would be worth it. Okay, so you have this sum array and you have this this H array. And you would need to transpose them. So it would go like this, right? So we would transpose H and sum into FFTWF complex. Then we would need to forward FFT H in sums, which would be max 4 FFTs. And then reverse FFT complex multiply H in sums, reverse FFT, max 4 FFTs. Normalize. Yo, what's up, Oops? Nice to see you. Thanks a lot. I hope you're doing well. I think it might just be necessary. It's painful though. It's not easy because we would need to. Okay, so we have a kernel, blur kernel. We have to create a new kernel that has a radius of can't sleep. Damn, that sucks. Yeah, I have found myself in that situation plenty of times where I just can't sleep. Benadryl doesn't fucking help, and I got an appointment. Yeah. So you'd have to set one up like this, the radius of 2. Yeah, yeah, it's always bad timing, yeah. Oh, I need to extern it. Yeah, I think that this is gonna work. It's not gonna be a walk in the park though. There's a lot of stuff we have to do to get this working. And I don't entirely know if it's going to be worth it. So that part sucks. I don't know where my kernels are. Do I not extern them? I have to. Yeah, I don't know where they are. Whatever. This is actually all my rendering stuff. I think that it's actually down here where I define the kernel struct. Yeah, it actually has to be because... Oh god, is it all the way at the bottom? Oh, that's fucking cursed. Whatever. Whatever. Yeah, the HLSL extern. All is gone. I got hardware acceleration. Yeah, it took me a while to figure out how to get it working for me. I had to get like a driver. Your NVIDIA GPU died? What? That's very sad to hear. I'm sorry to hear that. It's gonna have one beta. And that one beta will be 1.0F, I think. Rest doesn't matter. I don't entirely know if this is gonna work, but I'm just gonna try it. Let's just zero all of this, doesn't matter. And the H is fine. This M and S, I have no clue about. I think 0.3, 0.15 is pretty fine, but I'm not really sure. Anyway, I'm doing it this way because I don't know another way of computing it and shifting it to center. It would be like very complicated to do that math. So I'm just going to attempt to do it right like with this and pray. And just reuse the code and see if it works. So that will forward FFT it for us. So that's like not that bad. But now we need to I guess we'll call it that because that's what we're doing. We need to do we need also a place to store them. Thank you for demonstrating. Yeah, it's awesome for programming. I love how, you know, in the zone you can get with it. Can't go to Google with that. Yeah, extern is, it's crazy how they have that. Okay, my phone, I don't have ad block. Yeah, thanks for supporting the stream, by the way. That's me, Mr. Partner, putting the the mid-roll ads in. Sorry for that, but that is how it goes, I guess. Do we do max channels? Yeah. I'm all over it. That is me. I'm sorry for that. It's beautiful, the HLSL extern. I looked it up and it's a real thing. It's actually like a real thing. Like you can just like make a variable, declare it extern, and now you can literally just like, it's in the C program. Is that like insane? It's a real thing. Like what? That's just crazy. That's like fucking insane. But apparently it's a real thing. We have to do the forward FFT. How do I do a forward FFT? I've never done one before. Alright, good luck sleeping. I hope you get some rest. Where do I do the forward FFT? Why can I not find this? It's right here. It's right here. Yeah, it's right here. Wait, no, it's not here. What? Is it inside of here? Where do... What? Wait, I feel like I'm losing my mind. Wait, what? How do I not forward FFT? Bro? I'm missing a step. Wait, what? Oh no, I have it at the bottom of transpose to row major. Okay. I have it in a different function. I was like, what? That's crazy. Okay. Yeah, that was a moment there. Forward FFT is externed. Has to be. So now we're doing... Well, first of all, we have to put it in there. But assuming we put it in there, then we put in... I think we go to H preblur. Oh, we can't do this. It has to be this way. I think it's iterated like that. Yeah. Yeah, that sucks, but it's what it is. I suppose it's possible if you, I don't think it is possible. If you, like, maybe pass the pointer to a specific part of the array, I'm not really sure. I don't know if we can do one in place. I don't know if it's possible. Now I'm wondering, maybe we make H... My fucking ear. If we made H... Yeah, this might not work with the H problem. The H problem is a big problem. I guess we could pre-transpose H into... How hard would that be? You would have so many fucking cache misses if we do that. Like, that's disgusting. The amount of cache misses you have for doing this? Like, that's not okay. That's not good at all. But you could transpose it once, but then you're... You know, then you're paying the price there. But maybe it's better than... Technically, you want to iterate it the other way because of that, so... Oh shit. Okay, yeah, I have a decision to make. We have a decision to make. These plans are not padded. And therefore the kernel would need to be padded. Here's my 2 cents here. Here's my 2 cents. If we're gonna go and test this out, we just make pre-blur not padded. We just make pre-blur not padded, and then we just copy into it. Yeah. Yeah. So now you just have to go X, Y, and Z. Okay. I think we can do in place. I think in place is technically slower than a not in place FFT, but we can just like not care. And we have to do the exact same thing for some pre-blur. Okay. Now we have to do the complex multiplication, which before we did in line, so we could just like make it its own function. This complex multiply was supposed to do it, but it's or we could just, for now, we could just do it in line. I guess it's not like that big of a deal or whatever. We are going to need... Or we could just do it into one, because we only need it once, and then we have the out. Yeah. Whatever. We can use temp for now. We can just use temp, yeah. It doesn't need this because, well, you can just go into 0. It doesn't matter because temp is only used once. Hi, I just stumbled upon my stream. I've got a burning question. Why Windows XP? My friend said, I had an old computer in my garage, and my friend said, you should put Windows XP on it. And at first I thought, that's really stupid. Like, why would I do that? And then I was like, I started thinking about it, and I don't regret it because, like, my entire childhood was Windows XP. So it's very nostalgic for me, and also I like not having the internet on a computer. I like the ability to just know that every line of code in this project is kind of mine. Very little is not mine. So I like that, I don't like the ability to, like, go on the internet and then just see, hey, how do I do this? I like the ability of, like, to get code onto this computer, I have to write it or use a flash drive, So that's something that I really enjoy about it. But yeah. But I'm not a very typical person, so I usually do very weird things. So it's not anything new for me. And also, it's much more fun to write programs for old hardware, because if you write it on new hardware, then everything is optimized for you and everything just runs easy. I like the challenge of doing what I'm doing right now and pushing things to the limit, That is what I enjoy. I have to do this after, of course, though. It's like forcing myself. Yeah, exactly. That's a big part of it. I also, it's also like, if I write code for this system, it has to be very efficient, right? I cannot take the easy way out, ever. I have to do everything, very efficient. I have all of these different, like the SIMD is ridiculous that I'm doing in terms of, like, the vectorization for this project. That sort of stuff is much more interesting to me than, just like hoping that a modern compiler does it for me. I like writing the code myself, all of it myself. So that's a big thing. But I deal with the temptation, especially when I'm, like, banging my head against the wall for, like, hours on one specific thing, and, like, just, like, look it up. How do I do this? The internet feels like kind of such a poison sometimes, like that. I find so much more joy out of figuring it out myself. But yeah. And I would do the reverse. This is supposed to be, I forgot, this is this. There are some downsides to it, like there's no Vim, right? So Visual Studio, right? There's no, like, really neat, you know, I'm really slower. I'm much slower at programming here than when I'm like in Helix on my main computer. So there is that downside to it, but I don't really mind that very much. I think most people would find it kind of impossible to program on this, but I enjoy the challenge. I think you could just literally do this. Oh, no, you want to do temp. Yeah, you want to do temp. And it's going into, back into each preblur C. There. And then afterwards you do the sum. Yeah, when you're writing everything else, speed is not a, yeah, it's not a big concern, but it's mainly like multiple cursor stuff. Like when you do it Helix, like you can make a cursor that just is like, you know, 4 lines and then just like press W, select all the words and then delete all of them and stuff like that. Having to use the mouse like slows me down a lot when I'm, you know, programming on Visual Studio. So does a Vim port? Yeah, it's also like I've enjoyed using Visual Studio. I think if I was to compile things myself here, I think that it would not be good. Like you kind of do need Visual Studio when you're coding on Windows XP because of the way it compiles. Like I don't really trust, you know, getting like G++ or GCC to work on Windows XP and do optimizations good. I just don't, I wouldn't trust it, you know. Yeah. I also do like Visual Studio 2008. I like that it's period accurate and I do enjoy it. It's a love-hate relationship though. Like, I mean, there is no IntelliSense or syntax or like real syntax highlighting. You know, there's nothing. So now we have to normalize. So that's the final step. We can normalize when we put it back into H. So we go into H and sum. We go back into H and sum. And so now we have to transpose the opposite way, which is annoying, but yeah, so it's going to be the opposite thing. So yeah, oh, wait. Yeah, this does the blur for us. So we actually just go straight into US. The US. So we don't actually need that offset because we're not padding. So what is it? It's a US. And all I need is channels is right to be on the outside. So that is correct. So this, all we need is a C offset here. Yeah. My childhood was Windows XP, so the nostalgia is definitely a big part of it. You know, the vibes are there. Yeah. My childhood has become lost media. Exactly. I try not to be like too much of a boomer or whatever when it comes to this stuff, but like I don't even think I'm a boomer. It's kind of weird to think of myself as old. I'm not old really. I'm just like mid-20s or whatever, but like I don't know. Like I don't know. we had like a computer lab when I was like a kid or whatever, you know, and it was all, I think it was Windows XP or Windows 95. I don't really remember, but yeah, I remember that. And like the, you know, bookworm or whatever, that thing. And I remember my first game was Splinter Cell, which was a DirectX 9 game, believe it or not. I mean, what an impressive game that is, like, looking back on it. That game was, what, 2006, 2004 era? Unreal as well came out during that era, Unreal 2. Very impressive. 3D graphics stuff was coming out back then. Very, very impressive. So yeah. We don't care about H preflare after, it's just... And that is the transposition back. I have no clue if I'm doing this correct. But this is actually... This is actually just the blur itself. This does the entire blur and the transposition back. And I have no clue if it's going to be more efficient. But I guess we have to test it. I have no clue if I'm doing this correctly. It is kind of complicated. Yeah. I remember also that we had a computer lab running Windows 98 with an NT server. Yeah. Yeah. Things were weird back then because, like, computers were not even, like, we had, like, a family computer or whatever. Like, computers were not really, you know, like an everyone has a computer sort of thing. You know, this newer generation just does not understand that sort of magic of, you know, like, growing up while just, like, owning a computer, like, for yourself is so bizarre to me. Like, there was such, like, a magic sort of, you know, thing to it, where it was, like, Oz behind the curtain sort of thing, where, like, I only got to interact with computers, like, at school and rarely at home. Like, we had a family computer, right? So, like, I just can't imagine what it's like now to just have that at your disposal. I feel like it's a totally different sort of thing, you know. Whether it's a good or a bad thing, I'm not entirely sure. But oh, I didn't actually... That's a good thing. I didn't actually multi-thread this. We can pass in TD pointer T into here. I'm wondering if we can multi-thread it easily. I didn't even consider it, to be honest. I did not consider it. Yeah, that's difficult. I'm not really sure. The problem is that you have to have the FFTs done before you obviously get to the next step. And so that's not easy to multi-thread, obviously. unless you split it up into things where the threads meet up, obviously. So it's not trivial for sure. I almost feel pretty confident that we can just like go if t id equals 0 and just like see how it performs as is, and if it does what it's supposed to, and then we get all down and dirty later. Oh, I made some mistakes. What's new? I guess it's not to really say that like nowadays there aren't like impressive things being made in terms of computers. Like, even though I'm like not a huge like modern GPU sort of guy, I oh yeah, it's I don't know. It's weird. Like, I guess it just feels different for me. It feels more impressive, the stuff back then. I was never very interested in, why is this in making things photorealistic, and so oh. So for me, the modern like ray tracing stuff and all of that is kind of, I don't know, unnecessary. What are we doing? We're doing the pre-blur. Yeah, so okay, so obviously this isn't working. Obviously. It does take a bit slower, right? Obviously one is doing all the work, but I guess it could be a fault of the kernel itself. Like, I'm not necessarily sure if the kernel sums up to 1 guaranteed, and we could just be bleeding mass every time we go around, basically. That's kind of funny looking. Yeah. We're bleeding mass every time, maybe. We could print out the kernel itself just to test it. Oh, actually, do we? No, yeah, they're pre-allocated, right? Per kernel. Please go to the definition. Yeah. Yeah, they're stock, yeah. It's not very easy to print out the stuff, to be honest. It's not very easy to print out the stuff at all. So that's why I hate doing it. Let's just read through it before we do that so that I can make sure that we're not messing something up more obvious. This is 100% padded, yeah. It might also be the doing it in place. So that could be it as well. Oh, we did this. Whoops. Some S is not padded, yeah. That should not be padded either. Yeah. Not padded. Maybe in place isn't allowed. Maybe it's a different function call. We could literally just make 2 arrays too. It's not a big deal. I doubt that bug that I just fixed was the problem, but maybe it is. I don't know. Oh, that's kind of a bad sign. It looks very strange. Yeah. That's cool stuff. Thanks. Thanks, Rag. Sorry. I appreciate that. Yeah. Alright, let's try 2 different arrays. Yeah, so it goes into blur, and then we use blur yeah, it's very interesting. It is very, very interesting. Here's what I'm interested in. Maybe the radius is not being applied properly because we don't have this hard cap anymore. It's worth a shot. No. Yeah, I'm at the point where we should probably print it out. It's not very simple for us to do so. It's hard to do it in 3D is kind of the problem. I always have trouble with doing this in 3D. Whatever, man. Uh-oh. What? Okay, 32 times 32 times 32 is a lot. I do get it. I do fully understand the problem. You know. Oh, bro. Okay, we gotta end the program. I don't need... Okay. Yeah, that makes a lot of sense. That makes a lot of sense. We're just gonna step debug through it and then try and see. At 0, 0, we should have some signal. So we can probably just figure it out like that. Okay. Okay, so here we have... That's pretty small. That's really small. Okay, maybe we can't do that. But it's so cursed, man. Okay. Yeah, it sucks, but we have to actually write a function to pre-compute this kernel specifically for this one. Which, like, that really sucks. Because those kernels aren't guaranteed to sum up to 1, which we need a kernel that sums up to 1 because we don't want to just lose mass. So it sucks. It sucks a lot because it's not a trivial thing because we have to center that kernel around 0, 0. So if you think about it, right, the kernel, right, like we iterate over it, right, we compute its distance to the center, but you have to actually have the center be at 0, 0. So it's not an easy thing. So fun. Yeah, it was a pain to get this right the first time, and now I have to get it right a second time. So okay, let's figure it out, I guess. Basically, we start at the negative offset width, which is the half of the width, right? So, and then we iterate across. Yeah. So there is that. I think just like copy the whole thing in and then let's like figure it out from there. Okay. Okay, so let's actually look at how we pre-computed the Gaussian kernel beforehand. If I even have that in this file anymore. I probably... it's somewhere. Okay, don't make me go fish right now. I'm gonna have to go fish. Oh my god. I hate it when you have to go fish for that. Okay. We just walked right past it. So, that's good to know. Okay, so it's just this, right? Where S is just this. So that's no big deal. Okay. Okay, so there's no need to square root it. We just do this. Yeah. So we don't have to have any of this extra stuff. All we need is this, this to get the actual thing. Okay, I feel like we don't need any beta shit. Okay, that's just, yeah. Okay, hopefully that works. We don't have to divide after, I'm pretty sure. I don't think that we do. No. So all we have to do is execute the DFT, and that's it. Okay, let's pray that this works. Where's the error? These are all warnings. Identifier not found. Did I call it something different? I may have called it something entirely different. Is it just not included? Like, I guess it is not. Okay. Now what? Oh. That's also fair. Okay. Technically, you just do this, right? Why is it so slow? Oh, I'm in debug mode, that's why. I actually don't set this to 0. The 1. Nope. I feel like if I did it slightly wrong, then we would at least be getting some output, but us not getting any output is kind of a bad sign. It's possible that this is some RB and not some, or I think we got rid of some RB actually. Yeah. Yeah, maybe this idea won't work. That would be a real bummer, but maybe it just won't work. What did I just press? Go away, please. I don't need crystal reports. I wish that there was a way for me to like just isolate one thing and test that, but there kind of isn't. It has to all work or it doesn't work, you know. And it might just not all work. So let me just make sure that we're doing everything correctly. T is the forward FFT'd grid. Yeah, I think we do the exact same thing. Hold on a second. Oh shit. I myself forgot this. I forgot this. Oh man. That's what I forgot. I forgot to divide by grid size. That is why. Are we working? I think so. Yeah. Okay. Sorry about that. That took me so long to realize. Yeah, I myself said I said out loud that I was going to normalize it, and then I didn't normalize it. So I'm sorry. I did say that. I said I forgot what I said. I said something like that. I said, "Oh, I'm going to normalize it." And we can do that during this step, and then I didn't normalize it, so that's a bummer. Sorry, but whatever. The cool thing about this is that we can have a kernel of any radius now, which is very nifty. Very, very nifty indeed. Now, it might just make everything super blurry, but it may also make things interesting. also, if we want to be correct, we should always make sure that our sum is 1. So how do I mathematically do that? Let me just think for a second. Do I just have to divide by... I think I just have to divide by k-cells after, so yeah. We can do a lot of different things with it. We could change the radius to 2. I think 2 might be the sweet spot. 1 might also just be the best, even though it seems like, you know, whatever. But you can also change S and make it tighter in the center. Anyway, it's much faster, and it will go even faster when we properly hook it up to the threading, because right now it's single threaded. Things do seem to be dying out a bit, which is interesting. May have to play around with it a little bit. Yeah, I don't know. I think it's cool. I think it's alright. I don't really know if it's perfect, but the good thing about that whole FFT thing is that we can make a kernel of like literally whatever size we want, and that's pretty neat. That part is pretty neat. I almost kind of wonder if we blur before Sobel, what that would look like. That might be interesting. Yeah, it's cool. We have a glider. Except it's not gliding anymore. It was. We really gotta fix the atrocious fucking color palette. That part we have to fix. Yeah, it kind of sucks that I feel like normalizing it actually made it like work less. I don't know. Anyway, it's much faster. It's going to end up going down to 0.49 once I'm done with it. The question is, how do we get done with it? Well, the issue is that threading this is really difficult. So one of two things has to happen. We have to separate it into different functions, possibly. Possibly. We need to load them up, then execute the DFTs. So that needs to happen in order. Okay. I really need another coffee. Few ways I could do this. I could just split it up by the channels and then have the sum go to just this one goes to TID 0. And then we split up the channels evenly. I'm just trying to think, if they operate on totally different ones, does it just work? I think it does. I already have code for this somewhere. Okay. Okay, moment of truth. Isn't that a weird saying, moment of truth? That is kind of weird. Oh shit, wait a second. Oh shit. Wait, what? Wait, that was wrong? Okay, I think it works. $70. Some spikes to 80, some spikes to 95. But now it should scale. I'm happy with that. That's 71, 32, 55, 46. So 50, 50, 130, 200, 300. So just over 30 FPS currently. And we're not done in terms of the optimization. They should automatically auto-vectorize this, right? I don't have to do this by hand. Oh, you can't actually auto-vectorize this because of that. Well, that's unfortunate. Yeah, that sucks. Yeah, that does suck. Yeah, no way around that unless we actually put it in there in the first place. So that's unfortunate. Not much I can do about that. Not much I can do at all. Oh well. Oh well. Also, I'm realizing something else here, that technically speaking, channels since we're indexing everything this way, I think channels should be on the outside of our iteration. The reason why we're indexing it that way and not the other way is because we want to efficiently do SIMD regardless of channel count. So us having channel at the end of the iteration was not efficient. So it does kind of suck because it slows everything else down though, that we iterate it that way. But whatever, I guess. This also, you can't vectorize this because of fucking this shit. Sucks. We can vectorize this though. This we can vectorize. Something like that, I guess. I don't fucking know. I think so. I have no clue. I think that's you swap this, you swap, and then it's 0 times, and then you just multiply, right? And then you need to add 0 and 1 and 2 and 3 of that. How do I combine them? How do I combine them? I need another shuffle. I don't know how to do this type of shuffle though. So it's going to be trial and error. I think, so what we have to do is, it's going to be sub prod, and then some swap. And we need to use Rob's macro to do this. I have no clue if this is, you know, if this, I know that this is possible, but we had trouble doing this last time. This is, it should, maybe it's not included. It is. Okay, well, it's hallucinating it. It being there. It really thinks that it's there. It's not. Shuffle. I need to know what the bits do. Okay, but no, but I have two things that I'm shuffling into each other. Trying to figure out how to shuffle two registers into one another and it not being a mess like last time. Okay, there's no fucking nothing is actually telling me the answer. Okay, maybe we can still shuffle this. I just have no clue. Maybe this goes up to 8. Bit shifted by 6. 2. Yeah, I have no clue. I think I'm just going to have to actually step through it and see. Okay, like... I need out to equal something. I need out to equal something. S is permanently 0. I would love this to not be 0. That would be great, actually. Okay, now it's not 0. Okay, so we have some subprod and some swap. Okay, so if we need 4... Wait, so... Subprod is supposed to be going into 0. And it should have... Should be 0 minus 3. Okay, so this didn't go correct. Maybe it should have been... Oh. Maybe. One, 2, 7, 7, 7, 6, 4, 6. Yeah, there you go. 7, 7, 4, 6. Yeah, yeah. Okay, so I was doing it backwards. Okay, so subprod should have, because prod is 0 minus, so that should go upwards. So that's lane 0 and 2, 1 and 3. That would be that we want to get out, and then some swap should also be 0 and 3. So let's walk through it to make sure that we did that correctly. So we mold 6 times the swap B, and B is just blur, and then we shuffled it up. Oh, I forgot to fucking put this one back as well. So that was my bad. as it always is. Okay. So now B should get shuffled up. It does. So we get the swap B in the S, and then that's what this is doing. So we swapped B up, and then this times the 0. So we swapped B upwards. So the first lane is that's obvious. And then the second one isn't that obvious, but yeah, so it's some 0 times, yeah, so that's correct. Now, so that gives us that, yeah, so that's correct. And now we get the swap prod, which is that one, and we want to add it to itself, add them both together. And so in this case, that was -0, right? Was the other one, which was correct, right? Yeah. So then we shuffle that one up, so it should be that going to negative. Oh wait, no, we add them together. We add them together. So, but we're only looking at the first lane because we swapped it up. Yeah, so it's literally just that. And so, and then for the last one, we are just adding, we are putting some swap into, we want 519 to go into lane 2, and we want to keep a 0 in lane 4. But we need to keep 741 there, and we don't. Problem is that 0 doesn't even get... Wait, maybe it's the opposite way around. Hold on. So that's the so if we're thinking about it the opposite way around, that 0 and 1 are the starting ones. Why is this so complicated? Okay, they've got a diagram here. It's a very confusing fucking diagram, to be 100% honest with you. It is a very confusing fucking diagram. This is also the 120, no, this is 128-bit. It's incredibly confusing. I think that we have to use an 8-bit mask though to get this working. I don't think that we can do a this. I think we have to go back to doing B8. It's good to know that this one is 6 though, and that's 4. That's 2 and that's 0. This is really cursed though. The diagram doesn't really tell me much. I feel like I'm just poking around in the dark here. I'm gonna assume that this is it's in the same thing as theirs. So theirs goes 6, 4, 2, 0. That's that. So if we're thinking about that, so this would be 2, 3, 0, 1, right? So we need 1 there, but we need this to be I wonder if 4 indexes into this. No, you want that to have the... I have no fucking clue. That mentally made sense to me, but yeah, I don't know why it has to be so fucking confusing, to be honest. It's like there's no need for it to be that confusing. So we need to get 1 to 2. See, that's the same problem that we had before. Is that it takes the high word but then ignores the low word, like. Maybe you can only select from that one. I don't know. This fucking, it's so confusing for no reason. It's always so confusing. I don't think that you can just do... I don't think that you can do that. I don't think that that works. Oh my god, I just fucking quit out by accident. So we need to get 21 in the second word, but then it kills that word. Then we need 0 in the last word. Okay. So it went to 0. But we got 21 in the correct spot. Maybe I have to just... I don't think that they're in order. Let's think about it logically, okay? So that's 1, right? But then why does 0... It's not 1. Oh my god. Is it really that? Like, So you want to keep this in place then? So do you really, is it really 7? No, yeah, it is 3. I mean, that doesn't make any sense. Yeah, I think you have to do B8, but it still doesn't make any goddamn sense. Fucking Christ. Okay, so if we're to translate this to here, then this would be, can you please fucking, 0 is the last one. So if 0 is the last one, then we want 1 here, 5 here. No. 3 here, 7 there. I don't even know if you, no, it's not 7. It has to be relative. So in that case it would be, I think that's actually supposed to be 0. But how do you do 0? But everything else is 0. Makes no fucking sense. I mean, there's just too many permutations for us to just brute force it, is the problem. Ugh, man, like fucking Christ, dude. Why is it so complicated to do this? Fucking Christ, dude. Okay, well, at least we moved it this time, but we moved that down. Maybe that's actually supposed to be... How does it choose in case of a tie? It makes no fucking sense how it chooses in case of a tie. Like, if they're both 0, then what does it choose? Like, that makes no sense. That makes actually no sense. Like, dude. Okay, that might be it. I have a good feel about this one. I think. God fucking damn it. I need 9 to be in the first place. No, this isn't right at all. Oh my fucking god. No, how did -9 get over there? Oh my fucking god, this is so disgusting. This is awful. This is awful. This is awful. Okay, so let's think about this logically. So if that's 6, that's talking about that place. So 3. Okay, so that does make sense. That part makes sense. So if we want that to be that, then we have to do this. So it's the opposite of what we did. It's the other one. Yeah. Wait. No, we want this. But both of them are 0. Now both of them are 0. So how do we deal with that? What? How does that become 0? Okay, I'm just going to do the interleaving shit because I think that we could just cheat it with that, and that's just gonna be what it is. I don't know how to do it. I don't know how to do it. Sorry, I just can't figure it out. This exists, right? This has to exist, by the way. It does exist. It's an extra instruction, I think, but it is what it is. Okay, so what does this give us, though? What does this give us? YouTube is not receiving enough video. What does that mean? It should be. I don't know what that's about. Okay, listen. Let's try to figure out. Okay, so low unpack 0 and okay, so we want it the other way around. We want it the other way around. Okay, and now the last one, there has to be... And then there's move high-low, I think, is what we need to do. It's the last thing. Okay. Is it oh my fucking god, why is this so complicated? No, you're not listening to me. Stack Overflow, you're not doing what I'm telling you to do. Wonderful, wonderful. Okay, well, no one fucking knows either. There is a unpack that does what I need. I just don't know. It isn't this. Oh my god, man. Like I'm at the point where I might just like I mean, I can't even set to 0 and then just add them. I can't, because you can't do that. Oh my fucking god, this is so annoying. Yeah, moving. Maybe it is this, actually. I've never used this before, but maybe this is. Moves 2 from the high quad word to the low quad word. Maybe. 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 I just have to literally just check it to see if it does what I want it to do, I think. Maybe. No, you fucking bastard. Oh my god. Oh, dude, like, give me a fucking break, man. I don't want to swap the I want... Oh my god. Oh my god. Yeah, that's... Wait, actually... Wait, I am kind of crashing out for no reason. I think that this is actually what we need. Hold on. Okay, let's fucking focus right now and try to figure this out. Okay, so... Yeah, my browser is not enjoying me right now. Right. 17/11/66. Okay, so the swap happens. We multiply this times the swap, right? The fuck is happening right now? Dude, like what? I swear to God, this is leak. Like what the fuck is happening? Like, the fuck? Yeah, sorry for the stream quality just taking a dip. Like, what is the problem? YouTube just literally like, just I don't know what is going on. Sorry about that. That one's not on me. That one is on YouTube. Okay, so swapping. So we swap and then, so the weird thing here is that this, oh right, we add, wait. Do we need a swap there? Or do we just add across? No, we need to add them together. That makes sense. That does make sense. Okay, so what we want is this and this. That's all we want. Okay, so sum swap, we want 12 in the second place and 0 in the fourth place. And we don't get that. Or maybe we do. That gives us 12 in the second place, and then that gives us 0 in the last place. Maybe. 0 in the last place, and then 17. No, we need negative. We need negative 17 to be there, not positive 17. Oh my god, are you fucking kidding me that they're both in the high? Maybe it's fine that they're in the high. So we get 12 in the second, which is good, and then we get 9 in the high, which is good. But the problem is that negative 17, 0, those end up in the high word of the out low. And so we need negative 7, 0 at the end, and it ends up at the beginning. And 9, 12 at the start? At the start? Yeah. Okay, so move low, high then. Let's try move low, high. Okay. Oh man, this isn't even the bottleneck. I don't know why I decided to do this. I regret it a lot, actually. Okay, maybe I should have swapped them instead of changing the function, but it's too late now. Let's walk through it again. So the sum swap needs to be in the bottom right, and the sub needs to be in the top. So it needs to be 24/7, negative 53, 1160. So we got negative 247. Yeah, wait, no, we need positive 247. It's gotta be this way. Oh my god. Dude, this is gonna drive me nuts. Oh my god. This is so crazy. Okay. This has to be it. 111 3775. Sub top. Yes. Yep. And then 111. Okay, there we go. We got it. Okay, let's check it on a few before we get too excited here. So this should be 8 1 3 3.2. 3.28. Fuck. Oh wait, no. I'm stupid. That is correct. It's 2.7 that's supposed to be first. Okay, that's correct. 1.8. Yes, 1.8. Okay. I'm convinced that that's correct. The real test is storing it and then calling it a day. Yeah, I got no clue on that one. If this is gonna work. Error. What? Function does not take... Oh. Yeah, that is true. I do have to supply the word. That is... Not the word. The register. I don't know, bro. Okay, I feel like that is not correct. The stride is messed up, but we should be able to do 2 at a time. The fuck is this? What is this? What? Is this really the problem? Is this really a problem? No, this is something else. This is something else that's being a problem. What else did we change before this? Was it just making this multi-threaded? Okay, I don't want to lose this code, so I'm just going to copy it and then run it back. I want to see what else I changed before all of the SIMD Warzone here. Because apparently I changed something else that isn't this, so... I changed that. I changed that. Oh. Oh. My bad. I wrote plus equals 4 on on an iteration because I was toying with the idea of SIMDing it and then didn't get rid of that. So that's why there were holes in the cheese. Grommet. Yeah, I don't know about that. That does not seem correct. Well, technically it is SRT. Okay, maybe that is correct, actually. Oh, it is jittery. It is jittering. Alright, let's do a comparison with this versus the non-simmed and then figure out what to do next. No, it seems to be jittering regardless. Seems to be jittering regardless. to my eyes, it looks like a threading issue. So I've had issues like that before where it's a threading issue. I'm onto penetration testing and I was programming in Python. I want to know what projects I should do in Python before moving to C and do hard things like yours. I don't know. I don't know if there's anything in, specifically that I would, say for Python. I think like if you want to work in C, then go C. You know what I mean? Like there's nothing stopping you. There should be no like prerequisite for going into C, before you do C. I think if you want to do C, then just do C, I don't think that it's necessarily harder than Python. Yeah, it's definitely a threading issue. It is 100% a threading issue. And we can prove it even more by just doing the whole only calling this from the main thread. Oh, but then all of our multi-threaded logic is going to get in the way. Okay, well, maybe we just have to attack the problem head on and figure out what the problem is with the threading here. Not entirely sure. Oh, that would be why. We can't be touching the same temp, of course. The issue then becomes that this doesn't have an actual temp to go into. So we'd have to have a backup buffer. Or technically you could just do into assembler and then the point of it was to avoid a DFT in place. But we can just try that and do the DFT in place instead of, but yeah. Yeah, I'm pretty sure that the issue is resolved. No, I don't think so. It's hard to tell when we just set a mu-vel over it. It's kind of like yeah, there is still some jitteriness. Yeah, I see that. Oh, you can't actually do this because this is now that. Okay, so then you need another temp. That's fine. That's actually fine. Yeah, this is all. It's coming together quite nicely. Thanks. Thank you. All the SIMD is getting to me. Yeah, there is some jitteriness, I think. Yeah. It's barely noticeable, but I do notice it. Actually, maybe not. It's hard to tell. Oh yeah, yeah, there it is. There it is. Maybe there's something else where we're touching the same memory at some point here. I doubt it, but we should only be touching our dedicated ones. So we should never be touching the same memory ever. Good luck. Thank you. Good luck on your stuff as well. If you end up making something cool, feel free to share it with me. Claude just rewrote your entire DNA sequence in C. Rob. It's good to see you in troubling times like these. Difficult times. Fucking love Claude Code, bro. Can Claude Code tell me how to thread this fucking program? Dude, that would be sick, dude. Claude Code, tell those mate how to multi-thread this fucking program. Thanks, Claude Code. Put up a PR and I'll have all of them. Yeah, I'll send them a PR. Sure. How do I do that? Is there some sort of like application process? Do I gotta like... Maybe it's possible that I'm touching this while we touch the other stuff. I don't really believe that would be the... Oh my god. Nope. Nope. Never mind. Not oh my god. Git add, git commit m stuff. I'm not gonna git commit on Windows XP. You can't convince me to hack my own system. What, do you think I'm stupid? Come on, Rob. Come on, Rob. We're smarter than this. Fuck, dude. Yeah, listen. Okay, so let's just like keep going here, and then just like we're just gonna call this from the main thread just to prove that it's a threading issue in my brain. Okay, it has to be a threading issue. Otherwise there's some other problem going on, and if there's some other problem going on, then I'm worried. I think that this is fine now. Yeah, it's ballin' now. What is an SVN? I'm not enough of a tech bro to know what an SVN is. I know other things like that, like AVGN, that's an angry video game nerd. I know a VPN, that's a fucking virtual private network. Is that what it's virtual? Fucking oh no, it is. It is doing the bugging out. It is doing the bugging out sometimes. Oh my god. That is very unfortunate. Oh my god, what is that? The fuck is that, bro? Why? Why is it not smooth? Why is that smooth like butter? Maybe it's not a threading issue. SVN is a version control system. It's old school. Okay. So you're a boomer? Here's what Claude said. First off, breathe. Take a break. Ah. 200 Claude Max subscription. I see. I'm right there with him. I think that that's the solution. Not gonna lie, I think that's the solution. I really hate this shit. What I'm doing right now, I think it's cooked. I just think it's fucking cooked, man. It's so cooked that it's making me use, you know, the Zoomer lingo with the cooked. Man. Next project, make my own LLM. Rob. Rob, I can't even like do clever banter right now. I'm so pissed off. How many YouTubers do rage bait with this? Like, do they genuinely get pissed off? Or is it just me? Okay, so it's not doing it. It's not doing it. I'm the only non-AI tech tuber. That's not true. That is not true. Stop gassing me up like that. I'm not the last one. There's gotta be more. I got this video in my recommended the other day that was like, something like, yeah, it's not doing it. Something like, AI is bad and I am a tech guy or something. And it was this guy that was just like standing up with a mic talking about it. So I'm not. You're just too into AI, Rob. That they just you just don't get them in your recommended. So yeah, it's definitely this that's causing it. Oh god, that fucking blows, huh? That blows. I committed 50,000 lines of code today and got a 5% pay raise for it. I don't know what any of it does. You did not commit 50,000 lines of code today. Bro, that's a lot of code. What was the price of the Coke for that many lines of code? That's like $2,000 down the drain, Rob. Come on, Rob. You could have used that to pay for your Claude Max subscription. What are you gonna do now? Spent 2,000. Rob. Do you spend that much money on Claude fucking tokens that your bank calls you up? It's like, what is this, Claude? We're making sure that this isn't a fraudulent thing here. We've got $2,000 on Claude tokens today. Who is Claude? And what does he have to do with Rob? This is cursed. This is fucking cursed. I don't know. What am I supposed to do about this? What, do you think I know how to do this? I don't know how to do this. What if we just get rid of the normalization? That can't be right. Oh, maybe I should not be doing such a large kernel, bro. Or maybe the kernel size doesn't matter. There's something suspicious going on here, Rob. Don't you agree? Something suspicious going on here. I'm trying to do kernel convolution with FFTs. What do you know about that, Rob? What do you know about kernel convolution with FFTs? As a CRUD API, I attempted to cover every single edge case in the universe, including solar rate induced bit flips. That sounds intense. He's a bit jittery. Yeah, it's jittery. Yeah. No doubt. Oh, it's so jittery. I feel like I might be doing this wrong, Rob. Maybe I can't. Oh, I'm not even doing these in place. Rob, we might have a problem. My Schmalugi machine is boogling when it should be zoogling. Yeah? Really? What do you think about Chloe Grace Moretz? As an actress. Dude, I'm gonna fucking lose it. I'm gonna lose it. I'm gonna absolutely fucking capitulate. She hasn't done anything good in a decade. I don't think she was born. I don't think she acted a decade ago. What are you talking about? I don't think she was alive like a decade ago. So ever? Is that what it is? I don't think she's done anything good ever. She did kick ass. She did kick ass? Kick ass was not 10 years ago. I'm not. No. I'm not old. Wait, but also she did not do kick ass. She's like 10 years old. She's not old. She's not. Is she even in her 20s? She did not. That was not her in that movie. That was a 2010 movie? The fuck? That's crazy. She's almost 30. No, you're fucking lying. You're 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 lying. What the fuck are you talking about? Why is she 29? What? Why is she older than me? She looks like a child, and she plays a child in every fucking movie. Shut the fuck up. That's crazy. That's so crazy. That's insane. Oh my god, that's crazy. What the fuck? That is nutso. Hold on. I think we're gonna try to go back to the fucking offset width. Okay, we're gonna go back to the offset width and the offset height, and then we're just gonna pray from there. Did I just ask Claude? No, you fucking asshole. I looked it up on Google. Oh my god. See, now it's even more jittery. This is you when you don't have your Claude tokens. Oh my god. What the fuck are we doing, dude? That's EXPF. I'm smart. I know my shit. Fuck, man. Why does this not work? Does this mean that our kernels haven't been correct this whole time? It's just jittery as fuck, bro. God fucking damn it. Okay, let me try not normalizing it. No. Rob, you don't understand. You don't understand, Rob. It's cubed because it's in 3D, Rob. It's cubed. It has to be cubed. If that is the problem, I'm gonna be pissed though. I'll try it out. I'll give it a whirl. Let's do it. Let's do it right now. There you go. Hold. No, it's jittering, Rob. Rob. Did you ask Claude? Did you ask Claude? Be honest, Rob. Because it is not correct. You tried? Well, we all try. We all fail. We get back up again. Dude, it's so fucking cursed. Like, why? Maybe this index is wrong. Square root the disk. No, Rob. No, Rob. That's the wrong formula, bro. That's the wrong formula. That's exponential fall off, Rob. That's not Gaussian, bro. It's not Gaussian. Rob. I feel like it's not the kernel ain't the problem. The kernel ain't the problem. I mean, the kernel is the problem, but it's not the calculation of the kernel that's the problem. I think it's the centering of the kernel. I think the kernel isn't perfectly centered. That's what I think. Yeah, it's jittery. It's hard to tell, though, to be honest. Like, no one else would notice other than my ass, because I stare at this fucking screen for like 20 billion hours a fucking day and do this shit, so I feel like no one else would notice other than me. Yeah, it's like slightly jittery. It's Windows XP's fault. That's the Claude code speaking. No, I think it's the centering of my kernel. I think it's the centering of my kernel. I think I'm centering it wrong. Because I'm supposed to center it around 0, 0. And I think that I'm doing it wrong. Emod, name it to erob. This is the formula that I used to have. I took this formula from somebody else's project. Like straight up ripped it off of their GitHub, but how do I get real X, real Y? I call it emod. Kernel is asymmetric. What are you smoking? Are you smoking? How is it asymmetrical? Do you think it's supposed to be less than or equal to 0? So A is our current location, okay? And then B is the max. So if A is less than the max. Wait a second. Rx is never going to be greater than the max. Wait, what? No. Yeah. Wait, what? Maybe I'm not. Oh, it's less than 0. Oh yeah, if it's less than 0, then yeah. Then it's yeah. Yeah, because then it's wrapping around. It's wrapping around, Rob. And if A is greater than B, which it never will be, then it's A minus B, but it never will be. Yeah, it wraps around. Because if this is less than 0, then it adds the width, so it just goes around the other side. You get what I'm saying, Rob? Greater than, I really don't think so, bro, because that means that if it is 0, then it wraps around, but you do not want it to wrap around at 0. You want it to be 0 at 0. I just don't think so. I just don't think that that's it, bro. Yeah, bro, Rob, now nothing is happening. There's nothing going on anymore with the shit, bro. Masterpiece. It's just it's mad quiet in here, Rob. Yeah, I don't know about that one. Fucking Christ. Yeah, I mean, what do you say we get a beer and we forget about all this shit? Nah, yeah, this is it's not good. Did we try not normalizing it? I think we did, and then I started talking about like fucking Claude tokens or whatever the hell, but yeah, it's jittering. That is jittery as fuck. Yeah, I mean, man, John Lennon or Paul McCartney? Honestly, neither of them. I'm not a Beatles fan. I'm really not the craziest Beatles guy. Probably Paul, to be honest. Not the biggest John Lennon fan. I think the bro was pretty, I don't know. He's an interesting fellow. I think he was pretty, out of touch. But, you know. I used to have long hair and I looked like John Lennon, and then everybody would call me John Lennon too, so that probably like feeds into the, you know, little amount of spite that I have for John Lennon. You know? I wonder if here's a good question. What if I straight up what if I make them not estimate the plans? What if I instead make them measure? Paul was the genius? I mean, I'd argue, you know, genius is very generous, but I think that he was he was a good musician, yeah. Okay, okay, so, alright, so that doesn't work, because we can't do null with that, so, yeah. Estimate should work, though. I don't really know if, yeah, I mean, they made some good you know, stuff. But I don't know. Honestly, dude, everybody that I've met that was like really into the Beatles, they're undisputed asshole. Seriously, every single one. So I don't know if that's just like just the people that I've met, but yeah. Yeah. Once again, not a huge fan of either of the guys. But I'm a fan of Camus a little bit less. Probably because, honestly, I've met so many, like, philosophy dude bros, like, try and tell me, like, oh, depression isn't real because life is absurd. Like, go fuck yourself. Like, dude, genuinely, I've met so many of those dudes, especially when I was in college, like, that they had, like, this revelation that life was absurd, and now, oh my god, those people get on my fucking nerds, man. On my nerds? On my nerves. Yeah, they get on my nerves. So, but I also don't like Sartre. Sartre? I don't even know how to say his fucking name, to be honest. Sartre? I don't know. I've never actually read any of his fucking books, to be honest, so I haven't read The Second Sex either, so I'm not, like, you know, the best to speak on it, on any of it. But yeah. She just said he's working on my mental health. I'm kind of losing it, so I'm right there with her. Maybe we just give up on this for the day. I don't think we're making any fucking progress. Oh man, I wanted this to work, but it was kind of like a long shot because what I'm doing is I'm blurring the growth so that I can do a central difference on it, but doing it with an FFT is just it's outlandish. Take Klon's advice and take a breather. Yeah. What do you think about Lacan? Rob, what do you think about Lacan? Let's talk about the real questions right now. Let's do the real questions. I do set this to 0, right? I do. Absolutely. This is int-bound. Interesting. Too heavy? Come on, that's not too heavy. Come on. What do you mean too heavy? Too heavy? Come on, Rob. You can't just bring up like the Beatles and Camus, and now you're just like, Lacan is too heavy. What? We do set them to 0. We do. We absolutely do. The weird thing is that it looks like a threading issue to me. Looks like a threading issue to me. Oh, fuck. It is a threading issue. Oh my god, I got it. I figured it out. I figured it out. I figured it out. I figured it out. Oh, I figured it out. Oh, I figured it out. Oh, shit. You're gonna be so mad at me, Rob. You're gonna be so mad at me. This function is multi-threaded. Fuck off, Rob. And we are accumulating into H, but we aren't sure that the other threads have finished before we go into here. So it's possible that H isn't finished. Damn. Damn, am I a bad programmer or something? Damn, Rob. I'm a fraud. I'm a fraud or what? Alright, so this has to be its own thing. It has to be its own thing. Yeah, it has to be its own thing because this also transpose Sobel borders also has to be finished first. So yeah, we're gonna call this blur. I did it in the wrong order. And it sucks when you're stuck on something for a while and then you figure it out and then you're just like, oh, I was just stupid. Actually, bring this down here. Claude would have figured it out. Why are they so smooth, like a baby's bum? What the fuck am I even talking about, bro? What? Why? So now they're too smooth, can't win. Yeah, it's too smooth, too not smooth. Okay, we may have fucked with the kernel too much. I guess, like, I don't like, it feels like it's shrinking is the problem. Oh man, maybe I set this up wrong. Blur. We're only doing TID equals 0, but I have it set up to do all of it. I also need T is done true. I think. I don't really know if that's necessary anymore, but I don't really remember what the deal is. It should just be able to go in that order and then not have a problem. I don't need to change any code anywhere else. Oh my god. Why is everything always so... Okay, now there's nothing. What? Fucking, like, what? Did we touch anything here? Bro, like, did we fucking touch anything here? It was all this shit. All we did was touch that. Oh my fucking god, bro. I'm gonna fucking lose it. We didn't touch any... Okay, here's what I think. I think it is too smooth. Okay, so here's what I think. I think we did it correct, and now it is actually too smooth. Because we literally made the kernel smooth. Because that's what a Gaussian blur does. Like, newsflash, a Gaussian kernel actually makes it smooth. So I just dialed back the kernel and now it's like, has a little bit more pizzazz to it. But yeah, I think we fixed the issue. So I think that the Gaussian kernel is just being a Gaussian kernel, and we shouldn't like expect it to like be not a Gaussian kernel, because that would like go against its nature of like being a Gaussian kernel. We can bias it towards the center by turning S to 0.7, of course, something like that, and we can just call it a day, man. I don't want to look at this shit like ever again. Yeah, see, that's what I was thinking, bro. Like, so so when you got a kernel and you when you got a kernel and you spread it out a bit, it like, okay, the kernel is okay. Okay, we spread it out more by changing the S. I mean, genuinely like, what the fuck, right? But like, oh man. I don't think I understand how math works. Okay. What? Oh, you dick. Oh, you're being a dick. Oh, no. No, it did the thing. Oh. Alright. Time to restart the computer because it broke, so. That's DirectX 9 on Windows XP for you. Sometimes it just it just gets memory, and then it gets greedy and it wants all of the memory, and then it takes all the memory, and then it's like, oops, you have no memory now, even if it closes. So yeah. Is it bedtime for you? Okay, Rob. Sweet dreams. Sweet dreams. Something AI. I don't know. A dream of Sam Altman. Yeah, dude. It's funny because that guy, to me, he seems like a personable, chill guy. But he's also just a psychopath. I don't know. I feel like I'm always good at vibe checking people, but for him, I guess it failed because he like passes my vibe check filter. Like, he passes the vibe check for me. But I guess I'm just bad at vibe checking. Vibe checking? Like vibe coding? No, Rob. What? Wait, what? 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 What are we talking about, bro? It's the same issue? Oh, maybe we... Oh, bruh. There's just no movement, man. There's just no movement. Like, no matter which way I put the value, there's just no movement. Okay, now there is some. Maybe Rob was right. Maybe it is that we're square rooting the thing. Is coding for smart people I know? Stupid question. So, hot take on this one. I think coding is for stupid people because smart people would probably do something that makes them money. In fact, I think most successful, happy programmers don't program a lot. So I think that there's some sort of correlation there. Do you get what I mean? Like, I don't think that that most, yeah, that's what I think. Sorry if that question is not satisfactory. That answer is not satisfactory. Maybe we don't divide by K cells. I don't. Yep, and I'm stupid, and I spent 3 hours on simulating the for loop in recursion. Well, listen, it doesn't take a stupid person to be a bad programmer, because I'm a bad programmer. Because I'm a stupid person. Because I'm a, yeah. You get what I was saying. Okay, so this is more like it. This is more like it. All it took was unnormalizing the kernel, which I feel like it's not legal for us to do this. I think it's illegal for us to do this. Because we're supposed to divide it, bro. That's actually like what we're supposed to do, is divide it so that we so that the thing is normalized to 1, so that we don't actually just like grow in mass. Maybe it's just true. You gotta just like have a higher time step if you do this. And that's just the truth of it. When you get stuck in some problem in C, do you read the C programming book to get information or read other people's code? And I'm not talking about you now because I master it now. When I was learning C, is that what you're asking? When I was like, more like, when I would, like when I ran into like C problems, like specifically with the language. Honestly, I mean, I never referenced a book, that's for sure. I would just Google. Just literally Google. Like, I would Google the name of the error, you know? Google it as plain as possible. Do you want me to look at the recursion code or whatever that you're struggling with? I can try and look at it or whatever. I don't mind. Yeah, advection is stretched out on that axis, which some other issue entirely, but we can take a look at that. Yeah. Apparently it's only in advection, so something here. If I had to guess, yeah, exactly. It's this is not this is actually a padded thing. Both of these, I think. Yeah, I'm pretty sure that these are both padded now. Maybe not. No, it's simple. I solve it. I solve it and just that when I read others' code or ask AI to explain something, not write code or debugging because it's trashing that, I feel that I cheat. I mean, when you're learning, that's not cheating. That's not cheating if you're learning. Now, if you were to like just copy the code blindly, then I feel like that, you know, maybe that's cheating. But if you're learning, then it's fine, like asking for help, yeah. 100% valid. Is it padded? It is padded. It's 100% padded. Yeah, this should work. But it does not work. Are we sure that we actually pad velocity, or did we just like pretend? I know that F is padded, but maybe... No, velocity we do pad. We do pad velocity. Yeah, we pad it every time. Wonder if I did this wrong. I don't think I did, because it worked originally when I transferred it over. But maybe we made a mistake with it. Like, I don't even think I have the original one. No. Let's just try and go through it one by one. Yeah, that's correct. That's correct. Those are correct. Yeah, it's correct. Oh, you know what it might be? Oh, you know what it might be? We're padded, so we don't even need to wrap anymore. We don't need to wrap. So you can just have this. Oh, no, you do need to wrap, because this might go off the whole thing. But this doesn't need to be dealt with. But I don't think that would cause a bug like that. Maybe this isn't even a bug. Maybe it's just that I don't have it on Sobel. And we're doing this blur stuff, so it looks like a bug. I gotta make a button that does this, man. It's not hard, it's just I have to like have the mental fortitude to do such a thing. Yeah, this is fine. Yeah, it's fine. I gotta turn off backface culling. That's what I gotta do. It's funny when I start to learn recursion, I feel like an Inception movie. Yeah. Yeah, I mean, recursion is tough. It's also very tough to debug what's going on under the hood, yeah. So I definitely understand where you're coming from with that. But it also, I mean, it's also a lot of fun. I think yeah, the backface culling is off. Yeah, I think, I don't know. Why are you trying to learn just recursion though? Is there anything specific that you are trying to do with it, or trying to figure out if the orb is still here? That's what I'm trying to do. Yeah, the orb is in here, which is concerning. That is concerning to me. So I gotta figure out why that is why that's incorrect. I think it may be because we fucked with the emod function or something like that. Maybe. No. Do we have any settings that are weird? No. We didn't change anything that touched that. And this is Sobel, right? It is Sobel. So we didn't change anything that touched Sobel. Unless for some reason we're blurring when we shouldn't be. But I mean, I don't think that we are. We didn't change anything that touched that. Oh, we did. We did this. Maybe this is wrong. We never really tested this out. I'm learning it to add a weapon to my arsenal. A chess engine. Yeah, it's good for a chess engine, that's for sure. That is for sure. Let's just try plus plus, I guess. Maybe we can try just legit just doing it manually, the growth formula. Oh, you know what? We don't actually do this. We don't actually... Oh. We don't actually do this, by... Yeah. We don't actually switch on channel there. We don't by the thread. I don't know if that's the bug, but definitely was incorrect. That's more correct. Still not correct though. Oh, you know what? Oh no, this isn't more correct. You're not supposed to split on C section. You're not. This is automatic. This is already split. I was wrong about that. The reason why it's supposed to be split like that already is because this is pre-split. So H is only 100% ready to go for these indices by the time it hits that. So yeah, but yeah, I don't know what the problem is. Maybe the problem isn't here, but we can like move the logic back to what it was and just for loop through it in line, but it's the same code. It is the same exact code. What? What is the problem? Oh. What else did we even touch? I don't know. We didn't touch any of this convolution stuff, did we? No. We didn't touch any of this. No. Did we touch any of this setup for the kernels? No. Oh, there it is. Oh my god, I was just being dumb. I had it on RT instead of SRT. Yeah, I was just being dumb. Whatever. Okay, let me see the profiling. So yeah, it looks pretty solid. Now central difference is at it's still, yeah, it's about even now. So it's now 87. So that's pretty solid. We still are bottlenecked by the simulation and not the meshes still, but yeah, it's definitely better. Definitely better. Yeah, now we can try this. Now that everything else is figured out, we can try this again. Mathematically, based on what we checked, it should be equivalent, but not entirely sure. Another way for us to actually test this, oh, this should be plus equals 2, by the way. Another way for us to test this is to literally just put it into the old one, like right here. And try this out, because this will be much more visible if this is wrong. Okay, that was different than what we had before. Okay, yeah, this is different. Oh, hold on, this is supposed to be C. And also to test this, it would be good to do the orb so that we know what's going on. Okay. Yeah, that sucks. It's kind of cool, but yeah. Yeah, it's wrong somehow. Oh, no, this is, yeah, this is, yeah. Also, this is supposed to be C, but, no, it's supposed to be 0, yeah. And I'm going to guess that if we do it just 1, it doesn't work either. Yeah. Yeah. Yeah, I might just like take a break, get another cup of coffee, and come back. I probably be gone for like 5 to 10 minutes. I know that this is wrong somewhere, and I know it's possible to fix it. I also know that this isn't really the bottleneck, but it still is an optimization we need to make. There is something wrong here, though. I know that this is possible. It has to be possible. It has to be. Hey Max, I was about to take a 5-minute break. I'm staring at some SIMD that does not want to work, and I stepped through it and it appears to work, but I guess we gotta step through it again. It appeared to work, but it's very, very confusing, this specific one. Right. Alright, let's step through it. Alright, so we have S, right? So that's real, imaginary, right? So this one is, yeah. So it's real, imaginary, from right to left. Real, imaginary, real, imaginary. So it's basically reversed of the way you're thinking about it. So prod is, we want to multiply real times real, imaginary times imaginary, and so we go straight across, right? We get prod, right? So that's -16 times that is going to be 7, -7. So that makes sense. Now subprod is, we are now subtracting the top from the bottom, which is we are taking the real and we're subtracting the imaginary, the prod that we just did. So if we look here, we did it right across, right? So this, the real times the real, and then the imaginary times the imaginary would be -300 times 0. So there it is, 0. So now we want to do 0 times 792. So we do a shuffle. Oh. Oh. Wait, what? Oh, shit. What? Wait. Wait, what? Oh, wait, no, this is a subtraction. This is not a multiplication. This is not a multiplication. Okay, I don't know why I thought that was a multiplication. This is a subtraction. Right. So it's real minus the imaginary. So it's not 792 minus 0. So it makes sense. So we get that there, and -153 there as well. So first and third slots have what we want. Now we need to do this. So we have B, which is the kernel, and then we shuffle it, right? We shuffle it so that we get the opposites, right? So That's correct. Yep. So we just shift everything down and then we multiply it times s. So the 0 goes to 1 and the 1 goes to 0. So that's what happened there. Then the tricky part, right? So we do the multiplication. Now we need to add the top to the bottom. That's the real times the imaginary of b, which is 0. The real times the imaginary there. Yeah, so that's correct. And then what you get out is it in the first and the third. Right, so you want it to both be 0 because both of them have 0 there. So you want 0 and 0. So we want to get 0 and 0 out, and we're adding 0 and 0 together. So we should have 0, 0, and we don't. 0 plus 0. Yeah, okay, so this is where we go wrong. We want 0 plus 0. Oh, no, those are two separate things. Oh, right, we have imaginary times the real. Both of them matter. Okay. Okay, so negative 300, which is the imaginary, times the real. Wait, is 0? Oh no, the real is, yeah. Okay, so those do matter as well. So you get negative 151 out and negative 47, right? Okay, so now the real tricky part. So we have in 1 and 3 are the correct ones in both. So in SumSwap and in subprod, we have 1 and 3 which have the correct ones. So what we want to get is negative 792, negative 151, negative 153, and then negative 47. So we need 792 to be the first word, and immediately I see us swapping it to the incorrect position. So that's wrong. Should make sure that we do want negative 792 and then negative 151. So what we get out is negative 151 instead. So say out of high. Okay. Okay, so let's swap these. Let's swap these and then see what happens. I think the rest of it's correct. I think that the swap at the end is incorrect. Okay, so now in this case we want 846 0, 55, negative 92. And we get out negative 846, which is supposed to be 846, 0, negative 55, 92. Okay, so that's wrong. So we want to get 846 first. And we do get 846 first here. Get 846, 0. Which is exactly what we want, 846, 0. And then we want 55. Negative 92. So at this point we have it correct here. 846, 0, 55, 92. 846, 0, 55, negative 92. So this is correct in that we have it in the correct order. We do want 55, yeah. All we have to do is we need the high to the low. $55, negative 92. Why does it get negative though? Maybe this is different. Maybe this is the opposite way around. I already looked this up and it wasn't very moves 2 from the high quad word of the second argument to the low of the first. Okay, so it should be this. It should be this, and then I think. Okay. So 3347 0 negative 354 negative 66. 3347 0 negative 354 negative 66. See, I was right there. So I was right on that one. Now let's give it a shot. There it is. There it is. Okay. Just took a little bit of sitting here and doing the work, you know, and then we figured it out. So there you go. That's how you make an omelet. Okay. What's the problem? I guess that was the problem. And there we go. So we're down to 46. 40 fucking 6 because of that. That's pretty insane. Oh, wait a second. Never mind. I am being stupid. That's not actually entirely correct. Also, I forgot to do this. But yeah, this is not doing central difference. So we didn't really see the entire picture there. And the entire picture says, what does the profiling say? The profiling says that we are at 162. Wow. 159. Wow. Are we actually slower after doing that? Are we actually slower? Really? Wow. Wow, we really are slower. We're slower. Oh, shit. Gulp. Yeah. Oh, wait. We have to do this. We have to do this, of course. That's not correct, but I mean... It seems about the same, maybe a little bit faster. Maybe I'm doing it a fucked up way, I guess. I don't know. Maybe all these unpacks and moving, like, this is not, like, efficient. I suppose. Oh, I didn't increment it twice. Okay, now it says that it's faster. I think honestly it depends on the configuration. So we should make sure to have one with like 3 channels, and yeah, it's this much. It's nearly 200. So yeah, so 3 channels 200 is really bad, like really bad. We get a configuration with 3 channels, we test it, and it's less. It is less, yeah. Okay, I mean, I think that just pretty much seals the deal. Like, I don't know how to do this shit, I guess. I don't know. Maybe it automatically vectorizes this for me anyway. Like, so, yeah. Maybe that's just a thing where you just trust the compiler, I guess. But yeah, that sucks. That does suck. Man, I spent like all day on that. And I got it correct now, but it's slower. Man, that sucks. That fucking sucks. That's the worst feeling in the whole world. Whatever. Whatever, man. What's the next bottleneck? Is F? Yeah, F is pretty branchy, huh? I mean, technically not. Technically not, actually. Yeah, I wonder if... So let's do an experiment. Let's do a thought experiment here. Let's do this outside of here, and let's just literally see if it's faster. If that's faster, then... Yeah, it is. Hey, what am I doing? I'm doing a cellular simulation on Windows XP for fun. It's about the same. It's about the same. It's just a project of mine. I had this interest in Lenia because I think it's a really pretty simulation, and I like computer graphics, so it was kind of a natural kind of thing that I decided to go for. I love this hobby. Thanks. It's a lot of fun, yeah. $131, $132. Yeah. $142, $128. Yeah, I think. Hmm. 110, 106, 136. Does this actually profile well? Is what I was trying to figure out. If this is a SIMD, the other function. So I'm trying to test if I did it efficiently. $121. Seems about the same. I don't think that this was ever kind of a bottleneck, so I'm not really surprised. Like to do coding but for 3D prints. Yeah, that's really sick. Oh, actually, this isn't it at all. Hello? That is awesome. I always wanted to do coding for like CNC machines or something like that. Like that sounds like something that's like right up my alley. Right up my alley. Wow. Wow. Is that slower? Really? Slower by a little bit. Oh, this isn't plus equals 4, that's why. What code am I doing? I guess just C, you know. Okay, so let's see. That felt pretty fast. I'm just profiling right now. I'm just going back and forth and profiling to see if I'm doing things faster than I was previously. That's the goal. Yeah. Yeah, I mean, it is like the exact same speed, so I wonder how fast it is with soft clipping compared to not, you know. We can test that. It's fairly fast compared to the alternative, so I think we keep it. Have I ever tried to do your on drive? I'm not sure what you mean by that. What that means. What your on drive means. Yeah, we may be reaching the cap here, the maximum. What is the issue exactly now? I'm just trying to squeeze the absolute, you know, living daylights out of this thing. You know, in terms of the performance. That's all. I'm just trying to see if I can take it as far as it needs to go. But yeah. I think we may be just like reaching the cap, you know, the natural kind of cap of things. So I've optimized a lot though, but there's only so much that I can do, I guess. I mean, it's at the point where I'm optimizing things and then it turns out to be slower. So are these nested for loops necessary? Yeah, unfortunately. Unfortunately they are. They are indeed. It's a trade-off. You could technically, right, for thinking logically, you could just do int I equals 0, I less than grid size, you know, but then you wouldn't have x, y, and z to make these padded indices, which are padded so that we avoid modulus math in another part of the program. So it's kind of, you know, it's optimized to the point where it looks like it's not optimized, but yeah. My own digital drive, like in terms of like make some sort of file system, no, I haven't done I have not done that. We can get rid of some of this extra stuff. We can also pre-compute. We just have it here in C offset. CP offset for C, and then just like get that, and then instead of doing this by hand, everything pretty much should be padded, but yeah, we just like would one less for loop improve the entire complexity? What do you mean? Like, if I unrolled the channels manually, is that what you're asking? I've unrolled the channels in a lot of places, like here, for example. I have manually unrolled all of the channels, like that's why it's so long. But does that help anything? No, not really. I mean, like minimal, but it's kind of, you know. The thing is here, you know what I mean? Like, there's no way to make any of this faster. So this is kind of like the bottleneck, and it'll always be the bottleneck, and we can't make it any faster, so. That's really the bottleneck, like, this is like. Yeah. No, it's fine, it's just. I'm doing an impossible problem, you know, so it's like, whatever. It sucks because today I spent a lot of time writing a bunch of SIMD for this, and it turns out that it doesn't even work. Or no, that it works, but that it's slower than auto vectorization. I probably just wrote it wrong, or I don't understand how to do the shuffle properly, and so I'm doing an extra like unpack low and move here. So there's that, but it's slower than the auto vectorization in that case, so it's just getting to that point, I guess, where it sucks. I'm gonna like clean this up next, so you have an idea. Maybe stupid, but are you gonna say don't do it on Windows XP? That's a good idea. That one really got me, personally speaking. What if I threw my int variables in a vector? What? I want what he's smoking? What? What? I have an idea to optimize this. We can actually do a double for loop here. It looks kind of cursed, but actually us pre-computing alpha will oh, that alpha is not the other alpha. Well, fuck me, I guess. Us pre-computing this alpha will actually make it so that we can vectorize this and save the branch here. In theory, it should be faster. What do you mean by that? By int variables in a vector? What? What do you mean? What int variables and what vector? What do you mean about that one? I might need another. this is just an array. Oh shit. This either needs to be indexed by thread ID or we just have one per channel. Yeah. No, yeah, it needs to be actually, yeah, it needs to be per thread. And then you run into problems with that, yeah. Because this needs to get finished beforehand. Is there a step that I can piggyback off of with this? Okay, so this is F, and what comes before F? Kind of nothing comes before F. I mean, the Sobel convolution, I guess, and alpha would be computed with grid, back, GA, or alpha arrays, and all of those are available. So maybe we just pre-compute the alpha over here during our Sobel convolution. Yeah, no doubt. No, yeah, that's exactly what we do. And the idea is that we can vectorize this if that's already computed. Yes, it's more loops. It is more loops, actually. However, we get to go plus equals 4 here instead of plus plus. So that is faster. And if it's not faster, then I don't know. I fucking tried, I guess. But you do have to give it a shot. So we're just gonna put this in the array. Now we do need to have this array actually is going to need to be, I'm hungry and I need a coffee. Very true, very true. Truer words have never been said. True that. Does it need to be grid padded? Technically not. I don't think so. I don't think it does. No, these aren't. No, it doesn't need to be. It's just grid size. I don't know why alpha is grid padded. I don't think it needs to be, but whatever. Okay, so pre-alpha, it's going to be C offset plus IDX XYZ. And equals alpha. That's fine. You could also do it inline, it doesn't matter, but yeah. We'll also do alpha here. And we can vectorize, no we can't because of this, which is a problem, but that's why it's here, so that we can vectorize the other thing. And this PCIDX doesn't exist, right? So PIDX XYZ. We have to also do this over here. There. GA is not padded. Not padded, so there you go. Okay, so after that's pre-calculated, now literally all we have to do inside of here is load alpha from the pre-computed array, load all of these, and then just do the SIMD, and this is just plus equals 4, and that's like super easy. You just literally do this all the way down with all of these registers. Beautiful optimization. Index, by the way, is just XYZ. There we go. And then it's the alpha. This is actually pretty satisfying to do this. CIDX because we didn't pad it. And now we just do the thing. We need sorry if there's lag. I don't know why it's acting up today. How do I keep being focused for so long? Because when I don't focus, my brain does not like it. Let's just put it that way. So, as long as I keep writing the code, I keep my brain happy, and everybody likes it when my brain is happy. Sorry for the weird answer though. There we go. And that is that. And if I did it right, we should be a couple of microseconds faster. Function does not take... Oh, I meant to store. My bad. I meant to store. What's up, Nietzsche? How you doing? Sorry, I hit the mic. Okay. Just trying to make sure that everything looks okay. Holy shit! Look at that! That is some vectorization. Okay? That went from 50 whatever microseconds to 6. Holy shit. That's crazy. Okay, but now Sobel is a little bit longer because we pre-compute it. So that is where it went. It actually might be equivalent. let's actually see. Let's actually see it. Let's actually see 32, 33-ish. $33-ish, and then with it we go to how much? $33, and then with it we go to, yeah, so 30, yeah, so it's exactly the same. 40, yeah, it's exactly the same. Yeah, it's like 45, yeah, 45, yeah, that's about what it was before, so yeah. So this indirection is the real pain in the ass. So instead of this, what we should do is we should just make 4 different versions of this and then vectorize it. We should just do that, yeah. We should literally just do that so that we can vectorize this, because this is so vectorizable. You know what I mean? PowF is a thing, right? Yeah, I did this before with POW. There is POW, right? Well, turns out that that's not as easy as I thought. So Developers typically use third-party math libraries. Oh, fuck off. Yeah, we could just like pre-compute it as well. That's actually a valid thing. Just pre-compute a table of the POWs. Honestly, yeah. Because it's always going to be between 0 and 1. No, it's not guaranteed. Because theta A technically could be less than, yeah. So, Tough. It's a lot of assembly. Yeah, I want to vectorize you. For the meantime, I could just literally multiply this, just do it to the power of 2, because quite literally, like, this is not a very important parameter, to be honest, to tweak. It really isn't. It really isn't. So for the meantime, we could just do that times, yeah. The problem is, if we even had a table, it would stop vectorization, because I would still have to store, look up, and then or yeah, I would have to store, lookup, and then clamp, which would kind of defeat the entire purpose of vectorizing it. But I could see how fast we can get it. I bet that we could get it to the point where it's just 0 if I just did that. You know? Like, if I just committed to doing that, then, like, we could just get it to 0. Just as, like, a proof of concept sort of thing. We can just get it to 0. And then work our way back from there. I'm pretty sure that this is what I used before, right? This is a thing. That is absolutely a thing. Or I did it some other way before. It's... Oh, I have a function that does it. Abs PS. So this is the easy part, right? This is the easy part, and then we have to do. So of course we would end up, you know, with different things here, but just for the proof of concept here, we have the grid already loaded in. So all we need to do is the function. Is the function in the room with us? No, it is not. Oh, it's in that file. Okay, so we just have to divide it by theta a, and then clamp between 0 and 1, and then multiply. Yeah, put it to the power of 2 to the power between 0 and 1. So that's simple enough. Of course, we need should really have these pre-computed. Coding. So let's just do this. Div ps gr ta, and then we want to let's just, it's better to do. Okay. That should be equivalent. Yep. Super fast, like I said. That's basically 0. It went from 70 to 30. So like I said, that's, yeah. The only thing, so there's a caveat here, which is like this GR, right? You would need 4 different functions of this to do all of this, right? That's something, right? That's very easy for us to set up. What isn't easy for us to set up is that this to the power of n is not vectorizable. We can approximate it, but yeah. Yeah. Yeah, it sucks, but whatever. For now, n isn't going to do anything. But yeah, so that was the proof of concept. So that's that. It saves us about like 40, whatever that is, like microseconds or whatever. So but yeah. Another thing is that this stops vectorization, so having two of these functions and going plus equals 4 here makes a lot of sense as well. You would also need another, yeah, because of the border wall you need to do another one. I'm not sure how you do this. Also, does this even matter because we're... Oh no, I think that this does matter because of the... Does that matter? Now that we're wrapped manually, does that matter? I don't think it does. Now that we're wrapped, now that we're wrapped with the padding, I don't think that this is required. If it wasn't required, then that would really give us a lot of... As long as I see things wrap around, then I'm happy. That's what I'm looking out for right now. That's what that math is. It just wraps it. But I don't think that we need it anymore now that we're padded. It would certainly make our lives a lot easier. Because I don't know how I would necessarily do a floor F like that. Actually, I would have to do the exact same thing that I do here, and that's expensive. How slow is this? $35. And with this, yeah, we lose like 15 on this, and I don't think it's even necessary, but it's something to look at. I'm confident that we can vectorize this function down to 0, just like we did with F. We just need 3 different ones. No, 4 different ones. We need 2, and then 2 based on that. Yeah, 4. So That sucks. Add it to the pile. Add it to the pile. The growing pile of functions. Yeah. So right about here, we'd put it. Okay, I'm gonna get coffee. I'm, slightly out of it, so. I'm back. Hi, back. Hi, back indeed. Oh. Good morning, America. So interesting. The little, YouTube monetization doodads. I don't know. Is that am I a real streamer now? That I get to press the button? I pressed the button. I pressed the fucking button, dude. That was crazy. I never thought I'd see the day where I get to press the button. It says, play the ads now. It's like they do in the movies, you know what I mean? I never thought I'd be one of those people. It's really funny. It makes me feel powerful pressing the button. You know? Now, I'm not really sure if it's like, if it makes people feel great, you know? That they're getting ads, you know what I mean? Neither here nor there, you know? I don't really know how many ads. I put it on medium ads, okay? So I have really no clue if it's like an insane amount of ads. I also feel like 90% of people probably just, the ads are just, you know, they have ad block, right? So I feel like 90% of people, it doesn't matter anyway. It's only like people on their phone, right? So I feel like it's probably fine, right? You know? Probably. Sorry if you're annoyed. Okay? I try my best to please, and sometimes I fall short. Okay, once again, the better way to iterate. Well, the best way to iterate is to actually just fucking unroll the loop manually, which is what we'll do because we're assholes, and that's the way we do it in this household. Just unrolling loops all day. You know what I mean? You know what I mean. You get it. Okay. So we gotta lock in here. So let's see. Okay, so some things that we gotta preload, right? Marg. So gotta do that. We also gotta get the time step in here, you know. Gotta load that guy up. And other than that, I think we're good. The annoying thing is also this. Well, no, it's not. No, yeah, it is. Oh, fuck, man. Wait, no. We can... Oh, shit. Wait, no. I think we can do a little thing here. hold on, is pause array... Pause array is a global, okay. We can do a specific interesting thing here where we load in the pause array X for 4 in a row from the index. Yes. Yes. Absolutely. Understand it completely. PRX. Loadu PS. Loadu PS. I think we indexed it like IDX. I don't think it's padded. Maybe it is. No, it isn't. The pause array coming in clutch here. Because that preloads the 0.5 offset, so we don't have to do it. How's it going? It's going fantastic. Really? Not really. You know what happened, y'all? I spent like 3 hours working on this SIMD code for vectorizing this this complex multiplication thing, and it turned out to be slower than the auto vectorization that the compiler did. So love wasting time, you know. There's some wisdom in some like Chinese proverb about this, surely, but you know. The project is just at that point, though, where things start being a little less satisfying and more like you just try it out and it doesn't work, and then you're like, oh, well, I tried it. You know, you can't knock me for trying it. So this is velocity. So that's this. So... so we are going to Vx times the time step, and then we're going to clamp it. Min always before max. You know me. Yeah. Hard times make strong projects. Thanks. Yeah, I'm thinking like it's kind of getting to the point where I don't think that we're gonna have any breakthroughs anymore. It's just kind of like it's not gonna be easy, but we just kind of have to get out, you know. But yeah, that's what it is. It is fun doing all of this, like all this SIMD code. Kind of makes me want to like go back to all my old projects and see where I could do stuff like this, you know, get away with it, because it's very fun. It's very, very fun. Maybe I'm like the only person in the world that finds it fun, but it is fun. So now all we have to do is it's actually just all we have to do is, I'm not going to worry about this yet. This may be something that we do later, but all we have to do is store. I'm just going to store you into mux. This is padded, right? PCIDX? Yeah. And we just want to add ps the prx and that dx that we just did, because that's what this does, and we're not going to worry about this yet. Maybe in the future. Okay, we do have the wall here. This is the wall. Shout out anybody who knows the wall video by Only Afro, the of Dark Souls fame. That's a really funny video. I grew up with that fucking video. Anyway, you probably don't know it, so it's fine though. Anyway, we're just clamping between sigma and grid width minus etc. minus sigma. So that's kind of annoying, but whatever. We'll just make some extra registers for it. Sigma RG equals Okay. So now to mimic what this is doing, I think it's just nicer to just do this. I think we have registers to spare naturally. Let's just do, just so that it's clean so that we can see it. We add it and then we clamp it again. I'm kind of excited. I wonder when I publish this project if the creators of Lenia are going to see it. I'm really excited to see, you know, if they say anything about it. They are kind of like my heroes. They're like math wizards, you know what I mean? Like they're just like so cool. I hope one day I get as good as math as they are, you know. That's kind of like, I really admire them and their kind of creativity. But I do hope one day I get to be, you know, strong at math like they are. So they are kind of like my heroes. So I am kind of like trying to do them proud in a way. And not make just like a cheap knockoff or whatever. Kind of wanted to do my own spin on it. Okay, there you go. That's the code. For the first of the 4 functions that we have to do. Nobody said that it would be easy, but also nobody said that it would be this hard. Shout out Chris Martin. Shout out the chillhop today. Big chillhop guy. Okay. So I just want to kind of test if this is working. So that's what we're gonna do. I'm just gonna straight up drop it in and see. I'm actually just gonna straight up replace the function in here. I want to see the speed up. Okay, we have some problems. Redefinition of formal parameter t. That is very true. Okay, we're compiling. And okay, I feel like that's wrong. Oh my god, what was that? What was that? Whoa. Whoa. Wow, that's laggy. That is very laggy. CW. Wow. What? Did we do the thing where we ran out of L1 cache? Is that what happened? Did we do the thing? That would suck. I think we may have done the thing where we've run out of L1 cache. You hate to see it? You hate to see it? You hate to see it. You hate to see it. You hate to see it. I don't... Yeah, there's no way, right? There's actually no way that's true, right? Right. No. No, it can't be. Undeclared identifier. Shut up. Did we do the funny thing? Holy shit. Oh. We did say that we were going to manually unroll the channels, and then we never did. However, I don't think that would cause lag. I don't think that would cause lag. Let's just try this out. Yeah, that lag is weird. It's especially weird because it's not happening during any specific point in time, or during the mu point in time. It's or well, we don't even have. It's actually supposed to be here, but let's see if this is fine now. Okay. This is pretty standard. No lag. Then as soon as we do this, there is insane lag. And it's the type of lag where it's not profiling. Oh shit, hold on. No, this is float. It is float. The stream is still going. Did you make your appointment, or have you yet to go to your appointment? Yeah, I'm not really sure. Not yet. Okay. Let's just try single threading this specific part and then seeing if it still lags. Oh yeah, it does. Oh yeah, it does. Oh yeah, that's crunchy. The weird thing is that the lag ends up here instead of here where it belongs. So also sorry if there's weird lag going on. It's not entirely on me. I try to put the easy effects mic thing on like back in the old days, but yeah. Seems like it does not agree with me still. I wonder if it Oh yeah, it's lagging there. No, it wasn't lagging. Oh, reintegration lagged that time. It got longer and longer and longer and lagged more and more and more and more and more. See that? If I just do this, does it... I mean, it's going to be slow, but I just want to see, like, if somehow my stride is off or, like, what. Maybe it's a problem with me, like, reading out of bounds somewhere, or... Yeah, like, look at that lag. Oh, you know what it might be? Oh, no, it can't be that. I was thinking, like, maybe it was that thing that we deleted earlier. Maybe it is, though. Maybe it's literally just this that somehow... The code is perfectly copied, I think. Okay, so it appears to be that. Okay, so from what I can guess, the problem is that So now mu is just takes forever now. But from what I guess it is that yeah, mu taking that long is interesting because it we weren't even checking mu before because we had it over here. Yeah, so we need to actually do this. I think. It's either we do that or we clamp it, and I think we do this. The problem is that it's not easy to do this when we are vectorizing it. I think we do, it's this again. It's exactly this. I think it's exactly this. It's exactly this. This is fairly complex. We need all of these, which is fucked. Alright, I have no clue if that's gonna work, but that's what we did last time. Ah, fucking Christ. It is expensive, however, it's necessary, apparently, or else we end up basically going out of bounds. Not going out of bounds, we just infinitely kind of extend the mu until it's still doing it. Also, this does not seem to work. Yeah, it looks like this isn't working. I don't really know why. It's almost like I'm wondering if now my other implementation of this is wrong. Here I have absolute value, but this was supposed to do the exact same thing as that what I'm trying to do now. But I guess not. Oh man, you know, like, I feel like it's gotta be this, to be honest, but I just don't know why it would be that. But I feel like it has to be. It absolutely has to be that. It's either that or we actually are somehow out of regs. Which I have no clue how to test other than like us just like not doing anything other than making the regs and then seeing if it lags. There's actually no way to test. There's no way to test. I think it must be the pause array thing, but like now it's lagging, just like ever so slightly. The RI just starts bleeding into the RI over time. Like, as you can see, it's just getting worse and worse and worse. And I have no clue what would cause that in here. I mean, technically you're supposed to do this out here, right? But I wonder if this also happens with F. Let's do F. Doesn't appear to. Yeah, RI just stays. I don't know. I say we move on and assume that it's something to do with velocity. Update velocity might be the problem. Somehow, how it interacts with something else. Honestly, we should be updating the velocity before mu also, but, you know. In fact, like, we should probably just, like, do this in the same exact place that we do mu. I don't really see any reason to not. We should just, like, vectorize this as well. Let's just make it a second function. Really, we don't need to really check the length, to be honest. We can just normalize it automatically. So that's what we should do. This, how do we vectorize this? Or just, oh right, we have to square root. How do we, there is a way to do this, right? Sorry if there's lag. I've got to fix that for next time, but I think that there is. I think that there is. I just like searched it up and there's it says not. It says that it exists. Oh, it does exist. It was just telling me that it didn't exist. Okay, so whatever. What the hell, dude? Like, okay, here's what I'm gonna do. We're gonna do that. And we will do that. There we go. Okay, hopefully we can stop fucking lagging like that. Hopefully. Okay, we have the length. There we go. And now all we have to do is divide by it. Correct. Correctamundo. All right, so I'm going to inline this in the header, and that will be that. Oh, I forgot to, we're supposed to be adding on to it and then multiplying the damp. So that's what we have to do next. So multiply it, or add on to it, multiply the damp. Right. So okay, that's cool. So we vectorized that, and now we can just straight up get rid of that from the fucking thing, which is nice. I mean, yeah, don't know how much of a performance increase it's gonna be. That was probably auto vectorized anyway, so. I did a stupid thing. Where are you? Already defined in linear.obj. Oh. Did I not? Oh. I didn't static inline it. My bad. Okay. Interesting. Okay. Oh. No? Really? Is it all trending towards 0? Maybe I am supposed to do it after. No, I think it's the same. Fuck. Okay, maybe I messed this up. Len would never be below 0. Could also try not normalizing it. Same thing is happening. Really annoys me because I genuinely, like, I have no fucking clue because my code isn't wrong. It's just something memory-wise is off somewhere, I guess. Like, it has nothing to do with my code even, I think. It's just... It's very frustrating. Like, the code is right and the code is doing what it needs to do. It's just... I don't know, like, maybe it is this, but, like, I fucking doubt it, dude. This is clamped anyway, so... Yeah. Unless I'm just crazy and it also happens with this, like, I don't... Maybe it does. Like, yeah, it does. It almost feels like there's a memory leak or something somewhere. Like, I don't know. Like, if it's something that we did earlier or what. Ah, man. What the fuck is the problem? This is so strange. It's like... This is also incorrect. What the fuck? Like, wait, what the fuck are we talking about? Is there something that I like commented out that I forgot that I commented out? Like what? Is it like... No, it's not that. What? Oh, it's SRT. I keep forgetting, dude. For some reason, I keep fucking forgetting. That's SRT and not RT. Is there anything else that that is inside of reintegration? It's also the transposition. It's also these. Do you remember first year's progress in programming, like the first year of coding? Yeah. I did a lot of like terminal stuff. Yeah, let's try just profiling reintegration. Yeah, now it doesn't want to fucking do anything. Yeah, this one's crunchy. But I think that's just the rendering. I have a theory. I have a theory. I think it has something to do with what we did today with the blur. The Gaussian blur. I have a theory that for whatever reason it poisons the timers or something. Now it doesn't want to do it. Now it doesn't want to do it. I feel like I'm losing my mind. Like, I do wonder if I'm like somehow out of regs. Yeah, now it doesn't want to do it. I mean, if it fixed itself, then it fixed itself. Like, I mean, what, I'm going to argue with that? I'm not going to argue with that. Fine, you fixed yourself. Then, whatever, you win, I guess. We want to create a gate here where if len is greater than a certain amount, let's say if len is greater than 1, then we do this. We have to create a mask though, so that we can do that. And to do that, we've done it before here. This. So we want to check if fx is greater than len max rg. And so I think so you do toDiv and you and it. With len. and then you just divide by div x, div y, div z, and that's how you do it without branching. Neat. Now I'm confident we can do this times stamp and call that done. Nope. I mean, it's so bizarre. Actually, hold on. Maybe I'm not transcribing this right. Maybe I'm not transcribing the formula right. And I definitely do this, and I'm definitely going by 4, right? Yeah, I do go by 4. The fact that it's trending towards 0 makes me feel like I'm over normalizing, but the formula should be maybe it's the opposites. I feel like this is greater than that. I think that's the formula. That's the way that the other thing went. Is mx is greater than half width. That's the formula. So the square root does what I think it does, right? Yeah. Yeah, it does exactly what I think it does. Oh man, this man, today is just not my fucking day or something. I don't know. This is just really frustrating me today. I don't know. Yeah, it's just fucking like it's just as soon as I divide this, it just goes to shit. Or maybe it's multiplying times damp, but I don't think it is. Yeah, I don't think it is. Yeah, I mean, maybe I just leave it like this. It's a working state. It's a fast state. It's just kind of, you know, I don't really know about this stuff. For some reason, I can't get it. To divide properly with the, I feel like this mathematically has to be correct. It's just like, it's the most basic math of all time. There's nothing very special about it. So, I don't know. Also, something I noticed is that now that we have this set up, it's like, now what we did with the blur is now slow. For whatever reason. So I want to make sure that we didn't like set it to single threaded and then forget we didn't. Yeah. Yeah, the blur is now seeming to be very slow. Although maybe it's because I did this again in my confusion. What now? Oh, that's what now? Yo, what's up? I do have to go, but yeah, this is, it works, but it's just not, yeah, it's just, today was just not the progress that I wanted with the vectorization here. Yeah, that's a bummer. What I'm gonna do is I'm going to yeah, I should really. I'm pretty sure like it's all the blur is kind of the biggest problem. But I don't think that I can make it any faster. No, it's not. So then where is the bottleneck now? Like, where's the bottleneck now? Is it here? Not necessarily. It seems to be evenly between this and this, actually, so. This is also branchy. So that can also be optimized, I guess. But, yeah. This also we never multi-threaded because it was pain to do so. Because it's per kernel. Yeah, honestly, you know what? Why don't we have this per kernel? Oh, because of this. Okay, well, if we just, like, for the sake of argument, like, yeah, you have to do this. We want per kernel instead. Because then we could actually do K-section, I think. I didn't actually allow it to be multi-threaded, so. Oh. No, yeah. No, yeah. That's all fine. It all gets done before it ever gets here, so it's nothing for me to really worry about. Yeah, I think that just works. And you immediately see some improvement. You're now capping out at 130. And that is, I do have the whole thing, so that does have some improvement. We went from like 170 to 130. I think that was a pretty good test one, right? You want to test with 10 kernels, and then I immediately press the R button, so. So with 10 kernels, we're at about 130. Yeah, we hit 186 here too, spiked. So still not great, but yeah. Like I said, you can vectorize this too. I wish that there was a store and add. Is there a thing like that? So you have to you always have to load as well. Yeah. You do. So nothing I can do about that. But you could do this, right? And do all of that. You just cache the only tricky part is like the lookups. I'm not even sure if any of this is faster, to be honest, than just doing the regular bell. What's the regular bell function like? X minus m divided by s power of 2. Yeah, that's really expensive, so definitely can't do that. So you can reduce the branching though by putting it into 2 different functions for sure. So that's not that bad. The thing is that it's per channel, so instead of doing multiple functions, it's literally going to come down to this. It's literally, it would just look like this. You can do it inline. Do it inline. But unfortunately, you can't really vectorize this. It is kind of possible. You'd be doing something really weird with it though. You'd be basically, you would do all of this. And then store it out and then do the lookup. The real sucky part is that we normalize it here. But we don't transpose it, so if we don't transpose it, then there's no way to load it with that stride, so it's pointless. Yeah, bummer. I mean, whatever, dude. Now we're capping out 138, 149. 163 there. So the cap out here was 163.47. That's 200, 223, under 300. Yeah, it turns out that the bottleneck really isn't that anymore. It's really yeah. All right. Well, I think next time we're really running out of possibilities now. I think multi-threading FFT would be really nice, but I don't know if I'm going to be able to get FFTWF to compile properly. What is that lag? Yeah, so we're having like really weird shit go on with one thread just basically hanging. I don't know if that's my CPU or something that we did, but definitely some profiling has to happen. I have no clue what is happening with that, to be honest. It's really annoying. It just happens randomly. So I don't really know. I don't know why that is. It seems to only happen with central difference, so I'm kind of wondering if it has to do with the blur stuff that we did today, but yeah. Not sure. The blur stuff was kind of a long shot anyway. It is technically faster, but I don't know. Apparently it is thread safe, so I am allowed to do this, I'm pretty sure. where I split the work up, apparently, but maybe not. I have to profile it and catch it properly, but it's like I can't really, you know, it happens just randomly, this bug, so it's kind of hard to track it down. But anyway, some progress today. I mean, we are constantly, unless that bug happens, we are constantly below 30 FPS by a good margin. So yeah. By a solid margin. It may also be that we like have a read out of bounds during the mu, and then somehow it affects something over here. I don't know why that would happen, but it occurred the same time that we implemented the mu vectorization, so it literally happened at the exact same time. So I'm not really sure. But I was kind of worried that we were out of regs or something, but I don't think that we're out of regs. I think that I have plenty of L1 cache on this thing, so yeah. Anyway, I'll see you guys later. I'm tired. I may come back and work on this later tonight, though. I'm kind of like unsatisfied with the progress that I did today. Feel like I'm just kind of like hitting a wall with the optimization, which is completely fair. Yeah. Just out of curiosity before I go, I want to see what this would be like if I did this. I wonder, like, if we did all 4 threads on simulation and then somehow... Oh. Well... Oh, shit. Well, that's a bug right there. Like, it's gonna look laggy, but... Okay, something is wrong, I think. Oh, it's on SRT, that's why. I just wonder, like, what the performance increase is like. It really isn't that much. It's literally just this, like, it's a little bit better. But, okay, so having 3 doesn't really help us at all, so... Yeah, that is what it is. That was probably the bug right there, actually. That our thread didn't have the right bounds on the work it was doing. I know I didn't change the god-awful color today either. That was a bit laggy, but not too bad. Yeah. Yeah, capping out about 151. We spike pretty hard in that specific thing, but yeah, so 151. Yeah, this is definitely the bottleneck. Yeah. Maybe some more work that we could do. I have to keep taking a look at it and figure it out. Alright,